So, hey, welcome to this afternoon's deep dive on Reactive Spring, all things, quote, Reactive Spring. Building and testing reactive cloud-native Java microservices. I like to keep my titles really short, right? So, that's easy to say in a couple breaths. My name is Mark Heckler. I am a principal technologist and Spring developer advocate with Pivotal Software, Inc. Pivotal are the makers of such fine software components and products as Spring Boot, Spring Framework, Redis, RabbitMQ, Greenplum, Gemfire, huge contributor to Apache Tomcat, huge contributor to the Cloud Foundry Common Code Line. Perhaps you've heard of us. We're a tiny little startup out of Silicon Valley. Actually, a tiny little startup that just had its IPO, initial public offering. So we've gone public. So that's really exciting. I'm still doing the same thing I was the day before. I'll still be doing the same thing down the road. But the financial people are happy, so I'm happy. I blog semi-regularly, not as often as I'd like. But, I keep thinking it's 2018. Maybe this year will be better, right? So every chance I get, I do blog at thehecklers.com, my personal domain. Occasionally on the company site as well, but primarily on thehecklers.com. And I tweet very regularly at MKHeck. Is anyone here on Twitter? Really? No, not more than that? It's 2018. Twitter is the place where all of your favorite open source committers hang out. It's the best place to reach us, really. Twitter also, coincidentally, maybe turned a profit last year for the first time ever. So I'm pretty sure it's going to be in it for the long haul. It was kind of touch and go there for a while, but I think it's going to be here. I would encourage you to get on Twitter. I live on Twitter. I'm on Twitter from the time I wake up in the morning to the time I go to sleep at night. Sometimes I have been known to wake up in the middle of the night and grab my phone off of the nightstand in whatever hotel I happen to be living in that day, and tweet in the middle of the night. Probably a sad indication of my life, but there you have it. It is what it is. But that is the fastest way to reach me. If you have any questions, comments, or feedback, I would ask, because we do only have 3.5 hours, that you hold your questions and comments to the end. I will be here all week. I'm also here afterward. And I'll try to leave some time at the end, but I've got a lot of ground I want to cover, and I don't want to leave anything off the table. So if you hang on to them at the end, and I'll gladly answer them, or we can touch base afterward. The bad news is we have a short time, and it seems really strange to call 3.5 hours a short time, but it is here today. But the good news is we have a nearly unlimited amount of time afterward, barring any natural disasters or getting hit by a bus or anything like that. So that's the good side. Please do reach out to me. Twitter, like I said, is the fastest. But if you have something that just can't fit into 280 characters, or you hate Twitter, or what have you, I'm also a member of the slightly older and more established social network called Email. Is anyone on Email? Okay, a few more. I think it's going to be big. I think it has a future. So I'd advise you to get an email account. They're going fast. Like most of you, I have about a half a dozen email addresses. These are my favorites. Mark@thehecklers.com is it's the one I check the least infrequently. Okay, so I won't say I'm on it as much as Twitter. I'm definitely not, but I do try to check it from time to time to see if anything rolled in. Any Nigerian scams, because I've got my heart set on that too, because you never know, it could work. And my company address, mheckler@pivotal.io. So please do reach out if you have any questions, comments, and feedback. I'd love to hear it. Always looking for ways to improve or add or subtract or what have you. So anyway, who am I? Other than occasionally suffering from a bout of who am I? I have co-authored a couple of books. I have authored several blogs and blog posts. I've contributed content and code to other books, some of which even recognized me, which was kind of nice. Some didn't. No royalties, no recognition. It's just the way it is. Not bitter or anything. Anyway, I am a frequent conference speaker. This is my, dare I say, third time, I think, at DevOps UK. Is anyone here a first-timer? Wow, that's a lot of first-timers. So buckle up. It's a great conference. This is one of my all-time favorites. I'm not just saying that because I'm here. I really do love DevOps UK. They do so many things right. So yeah, I think you've got a great conference in store for you. Hopefully I can contribute to that in some small way. But I love it when they invite me back. It's always kind of nice. Little validation never hurts. So I am an architect and developer, and as you might guess from the next bullet point where most of my expertise lies, I was invited to be a Java champion, voted in a couple of years ago, 3 years ago I guess now, for ongoing contributions to the greater Java community. So if you had anything to do with that, if you contributed to that, thank you very much. Appreciate the vote of confidence. And I'm a seeker of a better way, as are you, or you wouldn't be here today, right? I think those of you who don't know me will know this very soon. I'm a history nut, particularly computing history, but any history is fun for me. And there's an old quote from Washington Irving, and it's a bit anachronistic, but I think it still applies quite well, actually, in a different way. But he said something along the lines of, when traveling by stagecoach, it's often good to shift and be bruised in a new place. And I think that's a good reminder that it's good to shift. It's good to learn new things. In our industry, sometimes we get distracted by the new shiny. It's not good to learn new things just because they're new things. It's good to learn new things because they bring solutions to problems that may have been intractable before. They bring solutions to problems that may be better than what we're currently working with. I think it's very important to learn new things and to learn when it makes sense to apply those new things. There is no golden hammer. I'll probably repeat that a time or two this afternoon. Reactive is no different. You shouldn't immediately rush out and replace everything you're doing with something different. That makes no sense whatsoever. But you'll find that you are adding another tool to your toolbox that can be useful in a wide variety of ways. So at least hopefully you'll find that out. And by the way, I do have links at the bottom, Twitter, my Twitter handle, MKHeck, and also Spring Data and Project Reactor. I'd encourage you to follow them, us, all of that. And more to keep up with what's going on, announcements. I also do have a video project that I'm going to be working on later this year on Spring Cloud Stream. So if you'd like to receive notifications and see what's going on and keep up with that, also that's the best way to do it. So anyway, oh, I almost forgot. If you wouldn't mind, I'd like to do a selfie with everyone, because that way I can prove to my boss that I was actually here doing something and working. Versus just sampling the coffee scene here in London, which, by the way, I will be doing. That's kind of my obsession. Let's see. Yes, that's fine. Okay, so, wow, this is we're gonna have to do this in a couple, 3 shots. Okay, so everyone smile and say open source. All right, moving over. Once more. Open source. All right, okay. So with my photographic skills, maybe one of those will turn out. So we'll see. So reactive programming, where were we? Right here. I love this quote by Rossen Stoyanchev, who's one of our Project Reactor team members. He said, in a nutshell, reactive programming is about non-blocking event-driven applications that scale with a small number of threads, with back pressure as a key ingredient, that aims to ensure producers do not overwhelm consumers. Now that packs a lot into one statement, right? So let's unpack it a little bit and kind of explore this a bit. First of all, non-blocking event-driven applications. Most of the world, most of technology is event-driven. Most of technology is not blocking. Even in our operating systems at the file system level, we have asynchronous operations. The JVM has imposed a little bit of an artificial environment on top of that, right? And it's very useful in a lot of ways, and it scales pretty well, but it's much easier for us to reason about and deal with. Because typically in imperative code in the JVM, when you make a request, a thread is created, and it services that request. So when you have more and more requests coming in, more and more connections, more and more threads, and it just scales out. And everything blocks. Most of those threads, by the way, are not doing anything most of the time because they're waiting on something else. They're waiting on an interaction, an exchange with a database to come back and confirm that something has been saved, or a file system, or an API call that it's making. So most of these threads, as they tend to scale out, a massive number of threads are idle. What happens in an asynchronous world, in a reactive world specifically, is that these applications become event-driven. So you insert an event loop. So you're not waiting, you're not scaling out with a massive number of threads. This tends to make them much more efficient because you have a smaller number of threads with a higher utilization. Sometimes people ask, what kind of a performance impact, what kind of a performance increase will you experience when you go to a reactive model? Probably the wrong question to ask, because for a very small number of connections, you may actually see a slight decrease. But what it gives you is ridiculous scalability, because your performance profile maintains a fairly consistent profile across a larger and larger and larger number of connections. So it's very, very resource friendly, shall we say. I already covered the next point. Never mind. Back pressure. Sometimes you talk about, or you hear about asynchronous programming. Asynchronous programming has been around for a long time. Even in the Java world, we've had access to asynchronicity for a while. The problem is that you get into things like callback hell. Anyone experience that? Nobody, right? Okay, yeah, just kidding. Asynchronicity by itself gives you a few tools, but they're rather uncomfortable and inadequate tools. There's no way, for instance, one of the things that separates reactive programming from pure asynchronous programming is that reactive programming has a way to insert back pressure, to limit the flow so that slower consumers aren't overwhelmed by a vast number of data values coming down the pipe. Now, you're not solving the problem that you may have a publisher or a producer that's producing a vast number of values very quickly, but what you're doing is shifting the ability to deal with that from the slower consumer back to the publisher, where you may be able to affect that more. You have more tools at your disposal to control that. So it gives you a way for slower consumers to say, I can only take 5 values at a time. Okay, I'm done with those, give me 5 more, or 10, or 1, or what have you. So that's something that it gives you. It also gives you a way to avoid getting into that callback hell, which I mentioned earlier, but I'll kind of go into that as we go along. So, let's see. A little history. I told you I'm a history nut. Early on, this was present in some languages before, but a lot of the reactive work kind of came together very nicely under Eric Meyer at Microsoft R&D. Go figure, Microsoft, right? This was back when it was the old Microsoft even. So Eric Meyer pioneered and led the development of the reactive extensions for .NET. You had other reactive extensions that came into being. Netflix kind of led the way with RxJava, but there were reactive extensions for JavaScript and Python and C++ and what have you. So this laid some very early groundwork. But none of that mattered, right? Because there had been no manifesto. Nothing in our industry happens before a manifesto happens, right? You all know that, right? I mean, this is BM before manifesto. Oh, that's not a good, let me rethink that one. But anyway, at some point, there were a lot of different implementations that were kind of coming into being for dealing with reactive streams. Why streams? Because most of the wait time is spent in the interactions, right? In the aforementioned file system interactions or database interactions or API calls. Most of those waits, most of that idle time, the inefficiencies are in the blocking and waiting for responses. So you had libraries that were kind of coming into being. You had also a recognition among various companies and organizations that, if we can all solve this problem separately, but if we don't cooperate to some degree, it's just going to make a mess for our users, for our consumers, right? So you had several companies who came together and created actually I'm getting a little bit ahead of myself. The Reactive Manifesto was published based on the work of a few people who came out and said, here are the things we feel like are important. The Reactive Streams initiative came about as a result of that, where companies like Twitter and Kazing and Red Hat and Lightbend at the time, TypeSafe, and Pivotal came together and said, we can all solve this problem separately, but it makes a lot of sense to have some degree of cooperation on this. So the Reactive Streams initiative was born. There are 4 basic components to the Reactive Streams initiative. One is the specification itself, of course. One is the API. One is the examples that they created to show kind of how things should work. And the fourth is arguably one of the most important things, which is the TCK, the Technology Compatibility Kit. Because what this allows everyone to do is create their own particular implementation that adheres to the Reactive Streams specification and is demonstrably adhering to the Reactive Streams specification. The Reactive Streams API actually has 4 interfaces. That's it, just 4. Very simple. It's deceptively simple, right? Because at this level, when you define something so small, you have to, it's very atomic, it's very primitive. And to do something with it, you have to have certain operations and operators, I should say. You have to have certain capabilities baked in, or you're constantly reinventing the wheel. Thus, it kind of makes sense, again, to choose one of the providers of these various libraries. But you can roll your own. Starting with Java 9, under Java Util Concurrent Flow, you have all 4 of these interfaces defined within Java itself. So there are 4 interfaces, as I mentioned. One is the publisher interface, which is kind of self-explanatory. One is a subscriber, which is also pretty self-explanatory. One is a subscription, which is the contract between a subscriber and a publisher. And then you have a processor, which actually implements both the subscriber and the publisher interface, which typically is involving some kind of a subscription to another publisher and then some manipulation and then providing that as a publisher to downstream subscribers. Excuse me. So again, it's very simple. It's very, very granular, very atomic. But the good news is you have a lot of different options in your implementations you can choose just out of the gate. Within Spring, we created Project Reactor. Now, there's a lot of cooperation that goes on behind the scenes, and actually, I shouldn't say behind the scenes, in public among the various different implementations. David Karnock, who is the project lead for RxJava 2, is actually one of our lead committers for Project Reactor. So we all get along, we all talk, we all try to make sure that everything works really well together so we can interoperate well. But we have a different take on things, as does Lightbend, as does Red Hat, as does Kazing. So our take is that we wanted some way to implement a fully non-blocking foundation that kind of builds on the basics found within Java 8. So things like the functional API, completable futures, the streams API, duration, things like that. So if you're already using those things, you'll find this is a very natural extension of that. One thing that I think we at Pivotal are doing right is that we didn't just come in and look at your existing stuff and say, oh, that's great, that 10 years of experience you've fought hard and won, throw that away. We're going to do everything entirely different. As you'll see as I go through the examples today, it's a very gradual on-ramp. I guess I should have asked here, who here works with Spring? Spring MVC? Okay, so you'll find this is a very natural outcropping. There's little context switching. And to me, this is critically important because you may be working on several projects that are using Spring MVC most of your days. And ideally, I mean, this would be great if we could start with a greenfield application all the time, but many times we start working in, and shifting things and adjusting things. Or we add a new application to our portfolio, but we're still dealing with a lot of existing production apps that are making our companies a lot of money, right? Which is good. That way we stay employed. So you have to be able to context switch. And if you're completely swapping your brain out every time you have to go work on a separate project and then swapping it back to go back to your existing work, there's a cost involved, right? So what we did is create a parallel packaging structure within the Spring framework. Right now you have a package called WebMVC. There's also now a package since Spring 5, Spring WebFlux. Why WebFlux? I will go on record saying right out of the gate, I'm not a big fan of that name. But I got voted down. To me, it makes me think of a vacuum cleaner. But it kind of does make sense, right? Because the publisher interface is a little bit broad. There are times that you will expect a value back. One value. I mean, think of your normal imperative code. You're expecting a return value of one thing. Or you might be expecting an iterable, right? So one or many. Well, it kind of makes sense to make that divide in the reactive world as well. So we have a mono, which returns 1 or 0 values. We also have a kind of publisher called a flux, which returns 0 up to an infinite number of values, maybe a certain set, maybe a lot, maybe an indeterminate number of values over an indeterminate amount of time. And you'll have operators that will work for both, that apply equally well, but you'll also have certain cases where they're particular to one or the other. So it kind of made sense to us to break those out. Thus the flux, right? Thus web flux. It's, like I said, I got outvoted, so don't blame me for the name. But the good news is it is parallel packaging. So it's twice the work for us, but less work for you, less context switching for you. It's a very natural extension. It's a very natural switch over when you're working on web flux or reactive-based applications versus imperative. And it's easy to switch back and forth. So I think that's one thing that we're doing exceedingly right. Yeah, for what it's worth. Also, non-blocking inter-process communication. Again, back pressure-ready network engines for HTTP, TCP, UDP. We support SSE, server-sent events, WebSocket, what have you. So you've got a lot of built-in support from the get-go. So I always find that it sticks better when you go to code. At least that's my experience, right? Because I think that's how you see it in action and understand it. Does anyone recognize this guy, by the way? Good, because I would be really worried if I were here in London and you didn't recognize Maurice Moss. This is one of my all-time favorite shows, by the way. I was so sad that there weren't more made of it. And also, it's not on Netflix in Mexico. I was just speaking in Mexico a couple weeks ago, and I was so disappointed that I couldn't encourage them to go to Netflix and just watch all of these. So anyway, probably fine. Does anyone remember which episode this was from, by the way? It's what? I'm trying to think if that ties in. It was the episode where they had the new emergency number, and then they kept dissing everything that was made in the UK, which, again, in Mexico, it was funny because I was talking to a friend of mine there, and he was talking about how the predominant viewpoint among Mexicans is that stuff produced in Mexico is not any good. You have to go outside of Mexico to get the good stuff. And I said, that's universal. That is absolutely universal. I mean, this whole episode was kind of centered around that. And of course, same thing with Made in America. It's like, it's going to break. If you import it, it's good stuff. It's just kind of universal. So hopefully this will not be how our demos go, because, things never go wrong in a live demo, right? Okay, so let's start off. Let's see, what else was I going to mention to you before I got rolling? Oh, I do try to start with fairly simple examples and kind of build out and kind of layer things on. So as we start off, we'll be going, rather slowly and gently, and then I add in more and build on top of that as we go. I am also going to try to take, instead of one 30-minute break in the middle after you've all dozed off, and I have to, maybe stop about an hour in, plus or minus, and take a 15-minute break. It'll take the guys that long to get down just to the restroom and back, probably. This is, how sometimes tech conferences, it's unfair one way or the other on the restrooms. This way, it's definitely unfair for the guys because they stick us down in the basement and across the street, I think. But anyway, so that's kind of the plan, the agenda. So let's get started. The first thing I want to do is kind of talk about the built-in support for reactive data sources within Spring Data. Spring Data, as of Spring Data K, it's different names, but it coincides K, the letter K and K as well, has support for 4 different reactive databases with fully reactive drivers. We do not support JPA, JDBC, any database without a reactive driver. We don't fake it out because that creates, it's adding potential complexity without giving you anything for it. It's the worst of all worlds, right? So there are 4 databases with fully reactive drivers currently: Redis, Couchbase, Cassandra, and Mongo. All 4 of those we have support for to deal with in a fully reactive manner. It's a little, each one is a little different, and I should ask this before I get started. Is there anybody here who works for one of those companies? Be honest now. Okay, good. So I can be honest. So I have opinions. We talk a lot of times about the Spring framework and Spring Boot being opinionated. So am I. So are you. I mean, we all have opinions, and I'd like to be fairly fairly honest about them. Doesn't mean they're right, but they're the ones that I hold loosely. So I will be giving you my kind of narrative as I go, and my pros and cons, and the things I like and the things I don't. But let's start with that, because when you have a reactive application, if you're not storing, if you're not retrieving reactively, again, you're just building on a blocking interaction, which is frustrating or worse. So let's start off. Does everyone know this, the Spring Initializer? This is your starting point for Spring Boot-based microservices on the net. You don't have to go here. You can create your Spring Boot applications just completely from scratch, should you want to. You can curl this. You can HTTP it, which I use quite frequently, but you can use this through your IDE. I like to go here because the website's so pretty. Clearly, I'm not a designer, but I like it. Anyway, it's very, very clear. It's also opinionated. So just a really quick tour of this. If you want to switch to the full version, you can. It does a lot of things for you. It makes a lot of opinions, surfaces them right out of the gate. So you don't have to do this, but you can. You can tweak every knob and lever should you want to. It's version synchronized. Spring Boot has a lot of different advantages. One is it simplifies your dependency management, so you don't have this long list of dependencies. You can have starters. Because you typically, well, you always, nearly always, will use certain libraries together, right? Spring Boot simplifies those into starters that kind of make sense. You can always exclude things. You can change versions should you want to. But if you don't have to do that, it simplifies your life dramatically. Also simplifies your deployment, because Spring Boot, we recommend you create a fat jar, an uber jar, a single deployable unit that's deployable anywhere there's a JVM. You can do a WAR file should you want to, but it is 2018, so it's good to stay up and do the things that make sense. So is anyone familiar with 12-factor apps? I don't want to go too far down the rabbit hole with this, but there are certain things, certain principles, 12 of them in fact, that have been codified actually by Heroku engineers early on, but kind of widely agreed upon by and large, with minor quibbles, about the things you need to do to make your application a good citizen of the cloud, right? Cloud native, if you will. So you have certain principles that go in, one of which is to bring your dependencies with you, to bundle, or as I like to say, bring your toys with you, so that nobody can change out things underneath you to a large degree and break your application. If somebody upgrades Tomcat or WebLogic or WebSphere at your workplace, your app breaks. Your customers, your users, now hate your app. They blame your app. They don't know it was some admin who didn't realize you had a dependency for that. So if you bring your dependencies with you, you control a lot of those potentially adverse outcomes. But you can do that. So you can choose WAR packaging should you want to. We won't, because it's 2018. You can choose the Java version. We supported out of the gate. Spring Framework 5 came out 1 week after Java 9. We initially, right out of the gate, supported Java 9. Java 10 is already fine. Java 11 is probably fine in the beta versions, or the early access versions, excuse me. But to get the goodies that we need, we're baselining at Java 8, which is what Spring Framework baselined last fall. So we'll start there. If you want to go back, if you're still using pre-Java 8, you can go back to the earlier versions of Spring Boot, 1.5.13, and Spring Framework 4.3. You just won't get the reactive bits, which is sad. And we're not here to talk about that. So we'll go with the current version. You can also develop in Java, Kotlin, or Groovy. Has anyone tried Kotlin? Yeah, I'm going to be doing a little bit with Kotlin as long as I don't run out of time. Again, hopefully, knock on whatever this is. Kotlin is an excellent language to pick up as a Java developer. If you haven't played with it, I strongly recommend you do. It has a lot of advantages over Java, as well as giving you a hint of where Java is going. I call it Java++. No trademarks, it's fine. So yeah, branch out a little bit. It's good stuff. So as hopefully you'll see. So I'm going to, I should mention also that another nice thing about Spring Boot is the version synchronization. You can obviously bring any dependencies you want to into a Spring Boot app, but if you choose from any of these that are represented here, they're version synchronized. So you don't have this version whack-a-mole game that you have to play because something broke. Oh my gosh, it's because version 3 of library A doesn't work with version 7 of library B. That stuff is battle tested. As long as you bring in the dependencies here. Do you have to? No, you can bring in your own. Can you change version numbers? Sure you can. but as long as you work, can use what's already been tested, it makes your life a heck of a lot simpler. So I like it. I'm going to go with the simple version and just get us started here. I'm going to just change this because I don't like examples. So I'll go to the Hecklers here for my artifacts. And for our first one, let's start off with Redis, because Redis is kind of the oddball among our various different reactive data sources, right? Redis does a lot more than a key value store, but primarily that's kind of what it has grown up being. It's a very good in-memory database with a persistent element to it, an aspect to it. It allows you to store maps and things like that, and you can even store very complex objects, which we will be, I won't say very, but we'll be storing a complex object here. We're kind of bending it to fit our will, so it's not exactly the easiest, most natural thing, but why not, right? Because we can. So when you do a demo, when you write demo code, it's always good to choose something that everybody can relate to, that applies to your organization or everybody's organization. Somehow it ties to their lives, because that way it makes sense just immediately, right? I don't know what ties to your lives, so I have to go with what ties to mine, what I'm obsessed with. So we're going to create a coffee catalog. We'll call this our coffee service, and we'll say coffee service Redis. So we'll start off with that. And I'm going to build this same basic thing with our 4 different databases so you can kind of get an idea of the similarities and the differences, and then we'll take it out from there. So we'll start with Redis. Again, I'm going to bring in the reactive bits. With Spring Web Flux, with the reactive web dependency here, it brings in web flux capabilities off the bat. It also brings in Netty. If you're used to using Spring MVC, you know that by default, Tomcat is bundled. You can swap that out, right? You can use Undertow, you can use Jetty. Same thing here, effectively. You can use any Servlet 3.1 compatible engine. So things like Tomcat 8, I guess it is, 8.1, 8. And Jetty and Undertow as well, past a version. But right out of the gate, we bundle it with Netty, because Netty's kind of been around the longest and is very, very solid. So we'll start with that. I'm also going to bring in my reactive Redis dependency. And then I'm going to bring in Lombok, because I'm a lazy developer. Lazy good, right? Not lazy bad. Because I think it makes sense to reduce boilerplate and to make things consistent. I've had a love-hate relationship over the years with Lombok. I loved it, then I hated it, now I'm back loving it. But is anybody here, have you tried Java 10 yet? Okay, a couple hands. That's actually surprising there are that many. But Java 9, yeah, the version nobody used, right? But version 10, Java 10 has what? What's the big news in Java 10? var, right? Okay, if you're a Kotlin developer, you're probably chuckling already. You're like, old news, right? But here's something I didn't know. I've used Lombok for years, off and on various projects, and I didn't realize until lately. I even blogged about this. It blew my mind so much. From like early versions of Lombok, you had the ability to do just that. var whatever equals whatever. Same thing with val, actually. So should you want to get your Lombok on, should you want to do Java 10 type stuff without going through the pain of dealing with Java 10 quite yet, you can do that with Lombok. So I was kind of excited. I know, it doesn't take much sometimes, right? Okay, so I will save this down, and let's see. Boom. Boom. Okay, so we'll go to our desktop. Let's open that up in our favorite IDE, which is NetBeans. Ha, just kidding. I actually don't. I'm joking. I mean, I like NetBeans. I like Eclipse less, but somewhat. So I prefer IntelliJ. It just kind of fits my style best. But we obviously have great support in NetBeans. There's a guy out of Italy, I think it is, Alex Filappa, who does a phenomenal job with the NetBeans plugin. And then Eclipse, we have a Spring Tool Suite build of Eclipse, which is pretty awesome. Each version, it just entices me a little bit more because it simplifies things like cloud deployments so nicely. VS Code support, which is increasingly awesome every day. It seems like Microsoft does something or somebody creates an additional plugin that does some cool stuff. Fully supporting VI, right? Vim, fine. Just don't use Emacs, please. Don't do that to yourself. Have some respect. Does anyone know my colleague Josh Long? He's here later this week. I don't think he's gotten here yet. I'm a VI guy. He's an Emacs guy, and I always tell him every time he fires up Emacs, a puppy dies. And he still does it. So I take that to mean he hates puppies. I don't know. Anyway, I have my water here and my coffee here. I did bring coffee because that's fuel, right? So coffee, water for my throat, and coffee for my soul. Okay, so I actually need to change this because I didn't realize I'd left this in Darkula. So font. So let's go here and let's bring it up to, wow, that's small. So I'll take it up to Ambiguous and we'll see how we do. Okay, so let's go to the, is that readable? Yes? Back? Yes? No? Okay. If you change your mind, just like wave. Okay. So we'll start there. I'm going to first go to my application.properties, which in a Spring Boot application is kind of the place where you put sensible defaults, right? Further explanation, happy to do it offline for those of you who may not have tried Spring Boot yet. But this is a good place to put your kind of sensible defaults like your server port, where you want, in this case, Netty to fire up. I don't have to do this by default. It goes to 8080, but I'm going to be doing this throughout each of my 4 different examples. So I'm kind of getting into the good habit. That's always a good thing to do. Let me start by defining our domain, right? So we will have a coffee class, kind of makes sense, right? And what kind of properties do we need? An ID, for instance, and a name. Yes, okay. So that's not bad. I'm going to use Lombok. So again, I'm going to create this as a data class. By annotating this with that data, Lombok will dutifully provide things like our getters and setters, our equals, our hash code, our toString, just by default, which makes things kind of nice. I'm also going to ask Lombok to provide a no-argument constructor for me and an all-args constructor for me. Now, you can write all this stuff, right? You can have your IDE generate all this, but this reduces our cognitive load. Every time we maintain our code, we don't have to go through and scroll through pages and pages of these getters and setters that are very much boilerplate. So I like it. Your mileage may vary. I'm going to do things, trying things a little bit differently. Again, be bruised in a new place. So what I'm going to do now is create, let's see, I'm going to define a couple of beans. So I'm going to create a bean which will, okay, let me step back a little bit. This is Redis. Again, Redis works very simply and easily if you're storing keys and values. A little less so when you're storing complex objects. Within Spring Data, typically when you have very consistent sets of capabilities that you want to provide for your data store, you have a Spring Data repository, a concept of a repository. And I'll be showing you that as we go through it. But there are things that you typically apply, operators that you apply to a repository, like the ability to find all, or delete all, or to find a particular record / document / object by its ID, or to delete it by its ID. So at a lower level, at a much lower level, it's all driven by templates. Redis, being kind of the oddball, so to speak, doesn't follow some of those same rules. It doesn't kind of make sense to follow that across the board with a repository object. But we still have template support, so we have to wire a few more things just to get things to work the way we want them to. Spring Boot's auto configuration is smart enough to know that we will need a Redis connection factory. We have brought in the dependency for reactive Redis, which means that it will provide us that a reactive Redis connection factory using Lettuce, the Lettuce driver. Lettuce is the only Redis driver that is reactive, at least at this point in time. There are others with cooler names like Jedis, like Jedis. I think that's so cool, but it's blocking, so we can't use that. So anyway, we have that auto-configured by default. We can define it should we want to, but we get the same thing. So the next thing we need to do is to create a reactive Redis operations, an object, a bean that will implement the reactive Redis operations interface for keys of type string and values of type coffee, right? So let's see, Redis operations, and I'm going to want to inject my reactive Redis connection factory so we can use that. So let's create our bean. So the first thing we need to do is to create a serializer, a Jackson to JSON Redis serializer for objects of type coffee. We'll call this cleverly enough serializer. I'm not great at naming things, as you'll soon see. Sorry. So I'm going to do a, let's see. Let's see. Oh, yes, this helps. New. And we'll use a string Redis serializer. Let's see. Have to stop and think about this because this is so different that every time I do this, I have to think about this a little bit differently. You'd think I would get this down by now. Okay, so that seems reasonably good. So the next thing that I need to do is to create a Redis serialization context or create a builder for said context. So I will context for, let's see, yep, new serialization context for a new string Redis serializer. And then, let's see, we need to create our Redis serialization context itself, right, for keys of type string, objects of type coffee. That's our context. We'll do that by using our, what happened there? Skipped builder, and assigning a value here of our serializer, and then doing a build. And then we'll return a new Reactive Redis template, injecting or passing our factory and our context. It's just so simple, right? It's a little bit more setup, admittedly, but this gets us what we need to operate with Redis in a more complex fashion, right? So let's get started. Now that we've set the table, so to speak, let's go ahead and, oh, actually I need to change that out. I got a little ahead of myself there. So that would be a coffee.class. Oh, that's much happier. Okay, yeah. Yep, that looks good. Okay, so I'm going to create a component, and we'll call this our data loader class. Data loader, and let's see, we want to inject our Reactive Redis connection factory. We'll just call that factory, and we'll also need to inject our Reactive Redis operations object or bean for, let's see, keys of type string and objects of type coffee. I call this coffee ops because I think it sounds really cool. And then we will add those to our constructor for constructor injection because that's the best practice, as we'll see when we start testing, right? So now I'm going to create a post construct method, private void load. Let's call it load. All right, so the first thing we want to do is create some values. Now this is a very data-driven presentation. It's garbage in, garbage out, right? So I need quality suggestions coming from you. We're going to be creating our coffee catalog. So we need to create some good coffees, right? So I'm going to start with a flux. Again, this is our 0 to n values publisher. And I'm going to create this flux with just these values. I'll scroll that up a little bit. There we go. So some kinds of coffee. I'll start with one from my hometown, Caldi Coffee. That's from St. Louis. I kind of live in the center of the U.S. I'm never there. It's a home I never visit. But there's a coffee roaster here called Caldi Coffee. It makes some excellent coffee. So let's see. We'll call this Caldi Redis. I'm just going to add Redis to everything so we can keep track, so it's very visual, so we can see what we're retrieving and keep track of that easier. Does anybody else have one that they like? Favorite coffee? What is it? Oh, Lavazza. Okay, so let's see. Lavazza Redis. Don't look for that on your shelves, your store shelves. It won't be there. Okay, anyone else? How do you spell that? K-I-M what? B-O, that's it. Oh, okay. Well, see, that was easier than I thought. That's good. Java Redis. How can you not love that one, right? Okay. Anyone else? What is it? Spelled? D-E-A-R. Really? Okay. I've never heard of that one. Oh, awesome. Where can I find that? Okay, next trip. I can already, I need to make notes of where by the way, I'm going to pull out my, my little outline so I don't skip anything. I have this bad habit of just kind of like, I don't mean to get off on a bunny trail here, but one time I had been really struggling to get this talk into 50 minutes. And the fastest I'd done it with the cutting out every bit of what I felt like was absolute down to the bare bones, I could get it to 52 minutes. But I had to go on, so I walked in and I got done in 48 minutes. And I was like, that is awesome. We have time for Q&A. So we launched into Q&A. It was a great session, walked out, and I realized I'd left out a whole section. So I have an outline, so I won't leave anything out, hopefully. If so, it won't be for lack of trying. Okay, so we've got some good coffees here. If anybody else thinks of one as we go through this, just stop me, yell it out. We'll add it to the mix. It's all fine. So we've got a flux of just these values. So I'm going to map, map. So these are names, right? So we're going to create a new coffee. And I'm going to just use a UUID random to grab our ID, to create our ID. And this is our coffee name. And then I'm going to flat map this. So let's see. We have our coffee ops dot ops for value, because these are our operations for values. And I'm going to set, which requires a string key, right? Well, we happen to have one that we know is unique. So actually, I need to do this. Silly me. Skipped right over that blithely. For each coffee, we're going to set our ID equal to our coffee ID. Kind of makes sense, right? And then we'll use our coffee itself for the coffee object. Kind of makes sense. Okay, and then publishers in general are lazy, like me, right? They don't do anything until there's a subscriber, which is good because that way you don't chew up a lot of processing bandwidth when nobody's listening. Now, there are exceptions to that, and as time goes on throughout the conversation here, I'll explain when those are. There are hot and cold publishers. But generally speaking, and I say this knowing full well that a just operation actually gives you a hot publisher, but regardless, generally speaking, you should think of publishers as being cold. Nothing happens until there is a terminal operation, like a stream. So we need to do something like subscribe. Suscribe in Espanol. So we're going to subscribe to that and kick off the party. So this is sufficient, but I like to see what's going on because I'm kind of OCD that way. So what I'm going to do is actually do a, I'm going to do, I'll just do a system.out print line like that, and that will show us what's happening within our flux as things happen. Now, we could do a little bit better than this. There are a couple problems with this right away. They're not bugs, because I make it a habit never to bug my code. That way I never have to debug my code. It's a huge time saver, right? Really? No one? You guys don't bug your code either. Okay, anyway. We're going to be restarting this several times. So what I want to do is each time this happens, we're going to try to insert these same records, which could get to be a little bit messy, right? So what I need to do to start off with is do a factory.getReactive connection, so I can operate at a little bit lower level, grab my server commands, and flush all. So right out of the gate, I'm going to make sure everything's cleaned out. Now, in an imperative world, we could do this, right? And we'd know that that statement would complete prior to moving on to the next one. But this is not how the reactive world works, because everything, again, is asynchronous. You're saying do this, and you're moving on. So we need some way of effectively doing that. Now, what we could do is just do a block. But this is non-blocking code, right? This is reactive. You're not supposed to block. And if you start littering your non-blocking code with block operations, you should probably question your life choices, right? So I'm going to use a then many. There are different ways you can do this. This is one of them. What a then many does is effectively blocks. It waits for the signal that everything is completed with the prior operation, and then it expects a publisher as its next step, as its next operation. Now, as luck would have it, we happen to have a publisher right here, right? A flux is a publisher. So I'm just going to bring that in, and that's what we have. Now, right now what we have is each one of these is saved. It will print out each one of these coffees. But how do we know for sure that this is all we have in our data store? Well, we've already seen what a then many can do, so let's just do another then many, right? Now with the repository, it's easy. You do a find all. It's a little more complex since we're dealing with a template engine. So we will do a coffeeops.keys and grab all of our keys. And then we will do a flat map for each of those keys. And we will do key, and we'll do a coffeeops.opsForValue.get, and do that. Now we can simplify this just a little bit with a method reference. Why does it do that? That's so ugly. I'm just going to do this my way because that's so much better. Just kidding. So we'll do a get, and there we have it. So that's a little cleaner. So that should work. Let's find out. Oh, that looks nice. Okay, so right down here we see that we have our coffees. They've been saved reactively. So that's good, but that's still a little light for an application. All we're doing is creating and saving some data. So the next thing we need to do is kind of build an API so we can verify this. I like to verify things. So I'm going to use a REST controller to do that. REST controller. So class coffee controller private final. Actually, all we need is our reactive Redis operations string coffee ops. Just love that name. Okay, and then we will expose an endpoint. We'll call it coffees. Let's see, public flux of coffee, get all coffees. So how do we do this? Return coffee ops dot keys. Once again, we'll grab all the keys dot flat map. So we'll do a coffee ops dot ops for value dot get. Actually, method reference get, and that's good. I mean that works, right? But what this is going to do is a REST controller by default waits for all values to be ready, and then it returns it in a single document, all of those values. As a way of showing you kind of as things trickle out, this is admittedly kind of a small scale example, but what I'm going to do is just delay each of these elements so that our flux publishes one of these per second. And that's very easy to do. Just provide helps when you, duration of seconds. There we go. Okay. So this will return one value per second. So let's go ahead and restart this. And I'm going to go over here and use my favorite HTTPy. I like it better than curl, by the way, because it's much prettier, as well as kind of allows you to shortcut things. As you can see, I didn't have to provide localhost as the host name because it assumes if you don't provide one, it's localhost. So let's see. Oh, well, I did forget one thing. That's why it's waiting and providing all of them at the end. Because we need to somehow notify our REST controller that, hey, we're actually only providing, don't wait. We're not providing all of the JSON in a single document. So I need to indicate that this produces a media type of text event stream value. This is the way we signal that we're producing a stream of server sent events. So now that I've done this right, this should be a much better demonstration. So let's try this again. Actually, let's do a clear, and we'll try it again. Well, that's embarrassing. Okay, so let's see here. So what did I miss? Produces media type, delay elements. This is good because I actually don't mind too badly when things go off the tracks because I have a whole room of people who can help me find them. So that's good. So we've got a flux. We're returning this. Yeah, this should be working. Oh, okay, so the code is fine. Because HTTPy assumes that you're doing the same thing on the receiving end. So we need to indicate to it that I'm expecting a stream of values. So there we go. This is actually a much better demonstration when I do everything right. Okay, so now we see what happens with a flux that produces values. Now, this isn't very sporadic, but fluxes can produce values regularly. It can produce values very sporadically, and maybe 3 values a second, and then wait 30 seconds for the next one, and then a week for the next one, which kind of adds to some complexities and difficulties testing, right? We'll talk about those as we get there. But this is a very simple example using Redis, Spring Data Redis, reactively to access and store our data. So let's go on and go to the next one, which is a bit more interesting, I think, which is Couchbase. And nobody here works for Couchbase? Okay, good, because it's not exactly my favorite. I mean, with all the stuff that I just went through with Redis, I still like Redis better, and that probably should tell you something. But anyway, Couchbase is a good database. I mean, it really is. It's just they expect you to do a little bit more stuff, more care and feeding, more hand-holding, which I don't like doing, right? I like to focus on business value-adding code. There are a few little extra ceremonial things there, so I will be pointing those out as we go. For anybody who may be listening in from Couchbase, so sorry. Fix these, please. So let's save this down and go back, and we'll open that. Open that. Gives me time to grab a drink. Okay. Okay. So the first thing, oops, why did it do that? Is anybody here using IntelliJ, the current like 2018.2 on Mac? And with the current, the most recent Java 8 JDK, I'm still using that for most of my demos. It's a weird combination. I find that it occasionally does some fruity stuff. So it occasionally switches or doesn't allow me to switch, or it completely eliminates my cursor. I feel like I'm running on Linux here, but it's whatever. I like Linux, by the way, no haters. I just, there were some interesting issues that were isolated on Linux for a long time. Now I'm starting to see some of these in Mac, and it's kind of disheartening. So, okay, so again, we start off with our server port. We'll put this on 8081 so we don't have any conflicts. I'm also going to provide a couple of different helpful hints to Couchbase. I need to provide the host name. It doesn't automatically grok that I'm going to be running this on localhost. Fair point, I guess, but it's a little, disappointing. I'm going to provide my bucket password. This is for my coffee database in Couchbase, so you'll probably be shocked. I'm just going to share this with you. Some of my closest friends here. Please don't share this with anyone else, because this would make me sad, but that's my super confidential password. Okay, so let's go to our main application. Once again, our domain, class, coffee, private, string ID. This is just at the wrong angle for my typing. I find it's a little weird. So private, string, name, not main, name. Okay, with Couchbase, we need to indicate that this is our ID, right? And this is a field. What else could it be? I don't know, but it's Couchbase. And then, of course, I need to indicate that this is a document. Store our coffee objects as documents, right? I'm still using Lombok, so this is a data class, no args constructor, all args constructor. Yes, that's fine. Take it. Okay. We do, though, have the ability to use repositories. Now, with Spring Data and Spring Boot is smart enough to know that when you extend an interface defined in Spring Data, so we're going to create our coffee repository, and we'll extend our reactive CRUD repository interface defined in Spring Data. Spring Boot says, hey, you have a database driver on your class path. Hey, you've extended this particular interface defined in Spring Data. I bet you want to talk to a database. I mean, it seems very obvious, right? And yet, outside of Spring, you still have to create glorious entity managers and entity manager factories and just fun stuff like that. But again, let's focus on our business value. So we're going to be storing objects of type coffee, no, not coffee repository, and IDs of type string. So this, in most worlds, is enough. But again, this is Couchbase. So I'm going to indicate that this is a view. We need to indicate what our views are that allow us to store and retrieve data. So I'm going to create a view which returns a flux of coffees. Yes. And we'll say find all by ID. Really doesn't matter at this point. But we need to specify our view name. And this is all. Now, I mentioned I was going to dish a little bit. If you go back here and we'll refresh, the Couchbase console lets you log in and see what's going on with Couchbase behind the scenes. Again, super secret password. So this is your dashboard. So I'm going to go under indexes and views. Most databases that we provide repository support for through Spring Data allow you to dynamically create things like your find all method. Not Couchbase. With Couchbase, and again, this isn't the do-all, end-all. This is primarily a dev test type of frustration, but you have to define views, and you have to define them in development. And then once you figure out that, yes, this is really what I want, yes, I super swear it is, then you have to promote them to production views. Then you can use them. Okay, so what you typically do, let's just say add a view. You define what document name, what the document is you're storing, in this case, coffee, and then you define a view name, in this case, all. So I've done this, right? Coffee, all, and then we go to our production views, and we see that I have a coffee, all, and now I can access my data. It's just a little annoying, but it is what it is. So this is what we have. Our document is coffee, our view name is all. Now we can get to our data. So I'm going to, let's see, I guess really all I need to do at this point is create our component. Again, this is our data loader component, loader. Let's see, private, final. I'm going to inject my coffee repository here. And let's get started. So we have a post construct method, private void load. So it gets a little simpler, and I'm going to actually just copy some of my values in, because we have some excellent values here. By and large, we're going to have to obviously change those, so we can replace Redis with couch. So now we have Caldi couch, Lavazza couch, Kimbo couch, Java couch, Deer Green Place couch. That actually sounds like a nice couch to have. Okay, so let's see. We have our values. So we're going to map each of those names once again to a new coffee, uuid.random.toString name, flat map. This gets a little bit simpler, right? We're going to do a repo save, method references for the win, and then a then many, and we'll do a repo.findAllById, and then a subscribe, system.out println, and just like before, we actually do need to clean things up just to make sure we have everything cleared out. So what we need to do with Couchbase is do a repo.findAllById, and then we have to flat map each of those values to our repo delete, which is a little cumbersome. Not horrible, just a little extra ceremony that you don't have to do anywhere else. And then, now we should have this. Okay, so let's run this, make sure that all works, that I haven't inadvertently inserted typos. I should say that I'm prone to typos. So the front row, thank you for being there. I'm counting on you to catch them before I hit build. No pressure. Everybody's like, I got this. No worries. Okay, so this is running. It's saving things down. So that's good, right? So let's go ahead and quickly create our REST controller so we can see what's happening. REST controller, class, coffee, controller, private, final, coffee repository. We'll insert that, inject that. And let's see, get mapping / coffees. Oops. Public flux coffee, get all coffees. Have to do this right. Okay, return repo.findAllById. Okay, so should work, right? So let's clear this out. http://8081/coffees. I didn't slow this down, so everything just comes back very quickly. But it gives my nice formatting that I love with HTTP, and we can carry on a little bit faster. I'm going to go through a couple more of these, and then we'll take a quick break, and then we'll come back and we'll dive deeper. So this is Couchbase, and that got us up and running pretty quickly. So let's go ahead and let's do Mongo. I love Mongo. You love Mongo? You love Mongo like I love Mongo? Mongo is super fast, right? So it's so fast, sometimes it's like it's not even saving anything. It's that fast. I call it the dev null of databases. Seriously, no Mongo reps here. Okay, good. I actually have my official Mongo sticker right here. See right here? Dev null. Yep, that's official. That's Mongo official. So I like Mongo. I mean, all kidding aside, it's a good database for the most part, and it mostly saves your data, so it's all right. So let's do this, right? Let's create a reactive data service using Mongo. What could go wrong? So let's open that up. Open, maximize. Application properties, server port, 8082, so we don't conflict. Let's go to our main application class. Boom, let's go down here, class, coffee. Okay, private string, ID, private string, name. Okay, with Mongo, we'll annotate this as our ID field. We need to indicate this is our document. Once again, with Lombok, this is our data class and our no-args constructor and all-args constructor. We want Lombok to provide that for us. Once again, we can create a repository by defining our interface, coffee repository, extends, reactive cred repository, coffee string. Okay, so now let's go ahead and create, and this is very simply done, create our data. So let's see, component, class, data loader, boom, private, final, coffee, repository, repo, inject, oh, yes, okay, post, construct, got a little lost there for a second, private, void, load, oh, you see, repo, dot, delete all, very simple. So we've already cleaned things up right off the bat, and Mongo made it easy. It makes it easy to delete. It's just, remember, it's just that good. So I'm going to create, actually I'm just going to go grab this. We'll create, well, I'll just grab those, that's fine. And here we go. See, this is one of the quirks. I can't get off of, yeah, so sorry, I have to do this the hard way. Click, thanks IntelliJ. Okay, I love IntelliJ, by the way. I'm not trying to bust their chops. This is some weird kind of convergence between this version of IntelliJ, this version of the JDK, and macOS. Go figure. So we already have defined. Oh, and I do need to replace Redis with Mongo. Replace all. Clear. Okay, so we have our coffees. So now I'm going to flat map. So each of our coffees, actually I can just do a repo save, method reference, then many, so a repo dot find all dot subscribe, system dot out print line. Okay, so, well, that's interesting. What did I forget? Oh, there we go. Oops. Hee. There we go. That's much nicer. Now, we could run this in the interim, but trust me, it works. That's like the most dangerous thing I've said so far today. But I'm sure if it doesn't work, we can fix it, right? So I'm going to create my my controller, coffee controller, private, final, coffee repository. We're going to inject that. And then let's create our endpoint. Get mapping / coffees. Public flux of coffee. Get all coffees. Have to spell right or it doesn't work. Return repo dot find all. Boom. Okay, so that should work. Let's try that. Let's find out. So we go back here, clear, and we'll go to our Mongo endpoint. Ooh, what happened there? Let's see. HTTP colon 8082 / coffees, right? Ease. Oh, hey, so this is good. So we've gone through 3 of these. Let's go ahead and just knock out Cassandra, because Cassandra is there when you really, really, really need to scale. Nothing has the scalability of Cassandra. It also actually stores your data all the time, so that's always a plus. So let's swap out Mongo for Cassandra. We'll just call it Cass for short. Boom, boom, Cassandra, reactive Cassandra. Oh, whoops. I am also going to add in a couple things that I'm going to be using here down the road, because I'm going to take this example after the break and expand this out a little bit. So I want to bring in Spring Boot Actuator, which, as it says, gives you production-ready features to help you monitor and manage your application, now fully reactive. I'm also going to bring in security, so that we can reactively secure our application. It would be very, very bad if we had a fully reactive application, but you couldn't log into it without blocking, right? So we need to have publishers and subscribers all the way down the chain, which we can do. So let's go ahead and do that. I will disable some of this until we just kind of get the lights on. So let's go to Cassandra, open, grab a quick drink. Okay, so maximize, open, whoops, and there we go again. Crazy. Yes, okay, so application properties, again, our server port in this case is 8083, right, for those keeping home score at home. We need to provide a key space name for Cassandra. It seems, I guess, reasonable enough. And then also the schema action, you don't have to put this. I like to do this because, again, I like low friction. So if it doesn't exist, go ahead and create my schema. Again, this is more of an issue on dev and test than it is in prod, obviously. So let's go ahead. And you know what? Just to speed things along, this is what abstractions do for you. So I'm going to go over here, and I'm just going to start copying here from our Mongo coffee service. Yay, it worked. Okay, copy, paste in. Now, a couple things are a little different. Instead of an @ID, we need to indicate that this is our primary key for Cassandra. And Cassandra is not a document store. It's a wide table store. The upshot of that is it's not entirely, I mean, there is a distinction, but it's not in practicality that much different. So we're going to annotate this as our @table. And then I'm going to change my my Mongos to Cassandra's here. Cassandra, replace all, and that's it. 2 annotation changes. Literally, that was it. And I changed the data, of course. So now, we should be able to run that, and we're off and going. Oh, I did forget to do one thing that I'm going to need. Oh, okay, a couple things. Remember I said I was going to disable security right out of the gate? I didn't. Oops. So let me just disable this for now. It's not the end of the world, but it does facilitate things just a little bit. And then I'm also going to add, yeah, that's true, include. Okay, so sometimes I do things that are expedient in demos that you should never do in production. This is one of them. So I'm making this very clear and advising you up front, do not do this at home. But this is a way to kick down the doors of security and expose all of Actuator's data to us so we can see it. But typically in a production app, you want to be very selective about how you do that. So just so you know, this is just for demo purposes. This particular setting does not exist otherwise, okay? So I'm going to restart this. Let's see here. So restart. Yes, that's fine. Okay. So we'll trust that that comes up. HTTP 8083, coffees. There we go. Okay. So just as a quick recap, what we've done is talked about what it means for an application to be reactive. We've talked about the 4 interfaces. We've also shown how to create reactive persistent microservices, right? The next step will be to take that and expand that quite a bit. So let's go ahead and take about a 15-minute break, and we'll start back up, and we'll really branch into the fun stuff. Deal? Time to hit the coffee. I always bring my own coffee and water because I never know for sure. One time I went to a meetup one evening and I thought, oh, meetups always have water, right? And if not, I don't drink soda as a general rule, but you can get by. I went to a meetup. Literally the only thing they had to drink was beer. And, I know there are the studies that say you actually code better after a beer or two. I don't find that to be the case. Not necessarily because I'm a lightweight on beer, which I am. I don't drink much, but primarily because anything other than water tends to make me a little raspier. So while I love coffee when I while I'm coding and presenting, I don't drink it as much, or I chase it with water shortly thereafter, because otherwise I get wispy. So by the time I was done with the presentation, I almost couldn't talk because all I had was beer. So I learned. So I always, bring my own supply here. Okay. All right. So those who came in late have to code the next section. Wow, this is a tough crowd. Okay. Those who came in later, just like, he didn't see me. Okay, so where were we? I need to break out my, I know pretty much where I'm going next. I just like to verify, trust but verify. All right, we've covered all the reactive data stuff. That's good. So let's go into expanding this a little bit. All right, so back to our home away from home, INITIALIZA. Okay, so I'm going to, we've cut a few corners so far to do what we've done. We've gone straight from repository to endpoints. So I'm going to instill a little bit of discipline here, just a little bit. So I'm going to actually create our internal API that we'll be using throughout the rest of our application, and then base our external API on that. Probably not a bad thing to do anyway. So I'm going to create my service API. We'll call this our coffee service. And this is what we'll use to base our internal API around. So I'm going to inject my coffee repository, right, repo. There we go. And we're going to build kind of the minimum viable API at this point. So we know that we're going to want to do certain things. We know we're going to want to return a flux of coffees, right? We'll just say all. And we know we're going to want to return a mono of type coffee, so we can grab a particular coffee. We'll call this by ID because we'll be referencing our ID to indicate which coffee we want to retrieve. And then one thing that you typically see in applications is the ability to get a little bit of operational visibility, right? Because if this is truly a coffee catalog and we're tracking what kind of coffees we offer and what kind of coffees we should offer, chances are we want to see what our coffee orders are doing. Because if we're stocking a coffee in our coffee shop, our theoretical, hypothetical coffee shop, we don't want to stock something that only one person orders once a year. We typically want to stock things that have high demand. So we need some way of tracking our coffee orders. I'm going to expand this a little bit and create an operational type of class called our coffee order class. And I'm going to keep track of course, a coffee ID and also when it's ordered. So, yep, date ordered. Okay, and I'm going to once again be using Lombok, at data, no constructor, and an all-args constructor. And that gets us everything we need for this particular minimum viable product. Okay, so to provide an interface to retrieve all of our coffees, we'll just do a return repo.find all. Yep, straight pass-through, that's okay. For our the ability to retrieve a particular coffee by its ID, return repo.find by ID, passing our ID, and that's pretty good. For our operational visibility, we want to be able to retrieve a flux of coffee orders, so we can see orders. So we can see what's happening. Is this coffee flying off the shelf, or is it not? Is it costing us just to keep it? So we'll keep track of our events, right? And we're going to reference our coffee ID to do that. Now, if we had a real coffee shop, and if we had real coffees and we were offering these things, we would be able to probably track this as it happens live and in real time. We don't. So I need to kind of fake it till we make it. So I'm going to generate some of these coffee orders just so we can kind of see what's going on. So I'm going to return a flux.generate, and I'm going to generate some values. So I'm going to create a sync and do a sync.next, and let's create some coffee orders. We're going to pass the coffee ID that we're requesting, of course. We're going to use that to construct a coffee order and then create just a date timestamp. That's fine. And again, this will generate just a ton of these things, just as fast as my little machine can create them. So I'm going to delay those down to 1 per second. That's nearly sufficient. IntelliJ is barking at me because it thinks I'm providing a flux of objects, so I do need to specify that I'm providing coffee orders here. And that's pretty good. Now, this is a little bit more involved, obviously, this particular method. It's not a pass-through. So this could be something that I've gotten wrong. I don't, because again, I don't bug my code. But just hypothetically, I could have done something wrong in this method. Everybody's playing along with this. That's really cool. I'm really not that good a coder, okay? But like they always say, every coder thinks they're the best coder, so maybe, I don't know. So anyway, if only there were a way to test code before you put it into production. Oh, if only there were some way to test code before production. I guess there is. Somebody told me once there was. So let's see if we can discover it. So I'm going to, let's see, go to this thing. And it looks like it should be possible. So let's do that. So I'm going to name this method events. Let's make it a little more descriptive, because it's always good to make your unit test descriptive. So get events. Let's take 10 events, and we'll see what we get there. So I need to do a couple of things first. This is kind of hitting it with that big hammer, and I'll start wide, and then we'll scope down a little bit, kind of the opposite of our build-out approach. But I'm going to start with this, and I'm going to I'm going to inject our coffee service. So our internal API, we're going to be using that. So private coffee service. I'll just shorten that to service. Okay, so let's see. What do I need to do? Well, I need to create a coffee, right? I need to find a coffee ID to use. So I'm going to string coffee ID equals. So let's see. Let's do a service dot events. Oops. Actually, all is what I want. Dot block first dot get ID. Now, unit tests are one place where it's okay to block with reactive code. Again, this gets to be a little more tricky. In imperative code, it's relatively, I emphasize relatively, simple to test, right? You issue a request, you get a response, you compare what you expected to get with what you got, and everything goes rather nicely. But what do you do when you have a sporadic flux? Sounds like that ought to be outlawed. But what do you do when you have a sporadic flux and you get 3 values right away and 3 values in a minute and 3 more values in a week? That gets to be very difficult to test, right? So the good news is the folks, our developers at Project Reactor, decided that this could be a problem. We need to simplify this. I always try to dress appropriately for my presentations. So if any of you haven't noticed that I'm wearing a Doctor Who shirt, now is the appropriate time to take note and be in awe. Any Whovians here? Seriously, gosh, we're in London. Come on. Okay, well, thank you very much. I know that it's not a thing that if you live or come to the UK that you have to be a Whovian, but I am deeply disappointed. This conference actually gets done Friday, right? Which is great because it gives you all weekend to catch up with New Who. I recommend starting with New Who if you're really, really into historical stuff and you can stand the, it's hard to go back, right? It's hard to go back prior to Eccleston, but, if you are really bored. But highly, highly encouraged. The reason I'm wearing a Doctor Who shirt is because with Reactor, you have the ability to time travel. How cool is that, right? So I'm going to show you how to time travel and compress things a little bit so that you can go through and deal with these fluxes that may take a little bit longer than you want to wait around for your unit test to complete. So we've grabbed our coffee ID. And the reason I'm doing this is, again, this is a reactive interaction with your data source. So when you're saying, give me all, you're doing a find all. We don't know what order those are going to come back. They're not going to come back in the order that we inserted them. They're not even going to be inserted in the order that we listed them, because it's reactive, right? And it's parallelizing. It's going across potentially multiple threads. I'll talk about that a little bit later as well. But the idea is that we don't care which one we get. We just want a coffee, and we want to grab that ID for that coffee, and then we can proceed with our test. So we're just doing a block first and grabbing the ID. So I'm going to use step verifier, which is in Reactor test, and I'm going to use the operation with virtual time. This is where it gets really funky. Yes, a big, what is it? What's the tenant quote? A big wibbly-wobbly, timey-wimey stuff? Yeah, okay, good. Okay, so I'm going to create a supplier here, and I'm going to use my service to grab the events for our particular coffee ID, and I'm going to take 10 of those. This is an example of back pressure. This is my subscriber saying, I can only take 10, only give me 10, and stop until I ask for more. So this is a very simple example of back pressure right off the bat. And then I'm going to await a certain amount of time. Now, since we're time traveling, we can just get crazy here, and we'll wait 10 hours. Now, we wrote the code, right? So we know that we're going to get one of these values every second. We wrote it. We know it. It obviously will work. But we're time travelers. We don't care. So we'll wait 10 hours. We won't really wait 10 hours. We're going to be out of here before 1:41 in the morning. But if we didn't have with virtual time, maybe not, right? So then I'm going to expect 10 values to come out of the other end of that, right? And then I'm going to verify it's complete. So let's see what happens. Hopefully this will work, right? Why wouldn't it? Oh, look at that. We got a green bar. And you know what that means, right? Either your code works or your test doesn't. So I always like to verify. So I'm just going to change this to, hopefully we'll get a failing test now. Because again, it's always good to trust but verify. So yep, okay, it failed, so that's good. And because I'm just a little OCD, I'm going to go ahead and change that back and rerun it one more time to make sure it works. Okay, so that worked. That's exactly what we expected it to do, right? Now, so I'm going to venture a little bit into testing now and show you kind of how things work as we go through this and why. I'm going to scope things down just a little bit because right now, again, I kind of used the big hammer on this. So I used all the context, the Spring Boot context. What I'm going to do is scope things down just a little bit, and I'm going to just do an @enable web flux annotation here. This allows us, it's called a test slice, and it allows us to bring in only the functionality we need to test, so it tests more quickly and more efficiently. So I'm going to, let's see, what do I need to bring in? My coffee, let's see, coffee service class. Okay, so that should be sufficient. I'm also going to, let's see, what else do I need to do? I'm going to create a mock bean for my private coffee repository, right? So that I can, instead of expecting a live data feed, I can just test what's happening with my internal API. And then I'm going to just create my coffee here, private coffee. Okay, so let's clean this up just a little bit. I'm going to do a before so I can set things up nicely. Public void setup. Okay, so I'm going to grab this. And let's define our coffee, actually. Actually, you know what? I don't, let's create our coffee here. Coffee equals new coffee. And let's just create a new coffee that we're going to be using kind of throughout our tests at this point. So I'm going to create just a bogus ID for this so we can easily identify it. Test coffee 999. And then I have to do this. It's so bad, it's good. I am the master of bad jokes, okay? My humor is legendary in how bad it is. So just to forewarn you, I should have said that first before I started the talk, shouldn't I? Would have cleared this place out. So has anybody heard of the coffee brand called Tester's Choice? Is that a thing here? No? Really? There is a truly horrible coffee brand in the U.S. called Taster's Choice. It is really wretched. I think it's only instant, actually, which ought to tell you a lot right there. But it's so bad. The pun is so bad. And it works for such a bad coffee that I just can't help myself. So Tester's Choice it is. Okay, so I'm going to just create a couple of mocks here. Mock, when. So when we do a repo.find all, then return flux.just of my coffee. So we're setting things up to where we can scope down our test just a little bit here. So I'm going to, oops, Makito, when repo.find by ID, find by ID. So we'll do a coffee.getID, then return a mono of just our coffee here. So that should get us up and running. So now, if I just go here and do a, well, here we go, coffee.getID. Now we should be back up and running, just to make sure I haven't horribly broken things. Oh, yes, I did. Let's see. Well, so I should be able to coffee service dot class, right? Cannot find symbol. Hold on a second. Boom, boom. Enable web flux. Yeah, it really doesn't, well, it's going to be a short demo, right? Okay, so I'll just work around this for now. I'll come back because obviously I'm brain cramping here. So what I'll do is just do this, and we'll just call this classes equals. Okay, so that should work. Famous last words, right?
You probably won't use the components then?
Let's come back to that. Yeah, because anyway, we will be revisiting this momentarily. Okay, so we've already got this. We see that this is working, but in the interest of 100% test coverage, which mileage varies, we're going to create a couple more tests. Public void. Let's see, we want to do an all, right? We want to test our all. We also probably want to test public void by ID, right? Let's see, and we've got our take 10, so that should be good. So let's see, to test our method here, step verifier with virtual time, service dot all dot, I don't really care about then await because we know it's going to return all together, so we will expect next coffee and verify complete. So let's run that, make sure that completes successfully. That seems happy. Okay, let's do basically the same thing here. Let's see, so step verifier with virtual time. And by the way, in this case, we know that we're going to be getting these back in a batch, so we could just use a step verifier create. I'll be showing you that as we go as well, so I'm just going to stick with the usual pattern here because, again, I like consistency. So this will be by ID. And we're going to pass our coffee ID. So let's see, dot expect next. Once again, we're expecting our coffee and verify complete. So we'll test that. And that all works nicely as we would expect. Okay, so just to run through and make sure everything is happy from start to finish, I'll run that. And everything completes. Oh, it's just one pass. Oh, hold on a second. 3 pass. Okay, so that's all good. So I'm going to just double check and make sure I haven't brain cramped on something too terrible here. So yeah, everything looks happy. Okay, so that's not bad. All right, so we've tested our internal API. Now we need to go back and rewrite our external API. So we're going to, instead of injecting our repository directly, because we have some additional capabilities with our internal API, like our events or our orders that we're grabbing. Actually, I should have named that orders. Why did I do that? That's so weird. Orders. That'll change things just a bit, just to make sure I don't... orders, obviously not functionality-wise, but again, OCD kicking in. Okay, so for our REST controller, we want to inject our coffee service here, service. So we once again change this, coffee service, service, service equals service. Okay, so here we have our external API. We're exposing service.all. Once again, we want to continue and provide the capability externally. So to be able to retrieve a mono by its ID, so get mapping. Actually, I'm going to move this up so I can make this at the controller level. So at request mapping, there we go. And then here we'll do a ID, dyslexia too. Okay, so public mono coffee by ID. We're going to use a path variable to extract that ID, and then return service dot by ID, passing the ID, and we're off. Okay, so finally, we want to be able to, again, expose externally our orders for that particular ID. So at ID, or slash ID rather, orders. Okay, and public flux of order, coffee orders, to orders. Once again, path variable for our ID, string ID, return. And this becomes a pass-through, right? So we grab our orders based on our ID. Now, once again, we need to indicate that this produces a media type of, oops, not that one, media type dot text event stream value. So we're back up and running. Should be. Let's find out. Actually, you know what? It'd be really cool if we could test this too, right? Wouldn't it be cool if we could test our external API the same way we did with our internal API? Wow. I know, testing. It's so exciting, right? Okay, so, but let's do this. Let's create a new test. So I'm going to test all the things, right? Okay, so now let's try this again. I'm going to run with my Spring runner.class, and at enable web flux. No. Web flux test. Ha 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 ha. Oh my gosh, I can't believe it was that silly. Okay, yes, I'm fine. What do you ask? So web flux test. At web flux test. Oh, so much better. I just feel better. Don't you feel better? Let's try this. Let's try this. Let's see. So test slices, they're a thing. Okay, so let's go back and test our external API now. So we need to, once again, let's see, bring in our coffee service.class. Okay, actually, I'm just going to copy some things in here. Because this makes things kind of trivial, past a point, we hope, right? So I'm actually not 100%, because instead of our coffee service, actually I want to bring in my coffee controller, right? So coffee controller, CTRLR, okay, that's fine. Okay. So we want to be able to test this. Now, Spring Web Flux has the ability, as you've seen so far, to develop services that are reactive. But if you have no way to have a reactive client, this becomes a drag pretty quickly, right? Because the idea is you're going to have a microservices architecture in which numerous instances of numerous microservices make demands on each other. They communicate with each other. And this becomes very difficult to do if you don't have a reactive web client. So we have a reactive web client. Again, none of us are very good at naming things, so we call it, catchily enough, web client. But there's also a web test client, which allows us to test things without having to spin up the entire context. So I'm going to be using that. So let's see how we do with that. Oh, I need to actually create a private web test client, call it client. Okay, so let's party. So for get all coffees, I'm going to do a step verifier dot, instead of with virtual time, I'm just going to create. There is one thing, and I've isolated this and I've talked with our Reactor team members. I'm actually going to be sitting down with them hopefully next week and talking about this and working through some kinks on this. When you're using server sent events currently and you're one step removed, and I'm actually not sure this is an issue, to be honest with you. When you let's go back over. It's easier to show. So here in here we are creating a lambda. We have a supplier, and this is dynamically evaluated. So our service orders, if we go back to service orders, you can see that we're doing a flux generate. Right here. So when that happens, it happens. Our supplier happens dynamically, so we can compress time because that's within our supplier lambda. What we're doing with the web test client is actually one step removed. We're kind of, figuratively speaking, going over the wire. So we can't compress time with that. So I'll show you what I would recommend to do to get that full testability without having to spin up the entire context, to have your live data, so on and so forth. So the short version of that is I'm going to be using create. Again, if you're not using server sent events, then it's a non-issue anyway. So I'm going to do a step verifier create, and I'm going to do a service. Oh, actually, I do. Let's see. Actually, I'm kind of going back here. Client.get dot Yuri. So I need to go to /coffees for this, right? Dot exchange, right? Dot expect. Let's see. Let's check our header. Actually, expect header. So that would be media type dot application JSON UTF. So we're going to test our headers. Let's see. Let's see. Dot. Hold on a second. Let's skip the headers for a second. Dot expect body. I know I'm going to be getting, in this case, a coffee. Let's see. Return result. Dot get response body. Okay. And then let's take one of those. Let's see. Take response body. Wow, I am just completely going off the track here. Let's see. So we've got the step verifier create. Yuri, expect body, return result. That returns a coffee, okay. Dot take. Well, let's just start this over here. Okay, so step verifier, let's do it with virtual time. Why not, right? So service, again, client.get.Yuri /coffees dot exchange dot return result coffee class dot get response body, which should return a flux, right? Actually, I need to go in here for a moment, and we'll do a take. There's my take. Okay, so I'm losing my mind, but that's a small loss, so that's cool. So we'll expect, actually, I only expect to get one in this case, because as you see up here, we've actually just provided one in our repository. So I'm going to expect that to be our coffee. Kind of makes sense, right? And then we'll verify complete. So that should give us what we need. Format that a little bit more nicely, and let's run that. Oh, test failed. Okay, let's see why we failed. No qualifying bean type of coffee service. Okay, so Okay. Null pointer exception. Okay, so, all right. Well, sorry, I didn't catch that. Web test client. Yes, I do. Okay, so shouldn't need the service, right? We do need the service. No. I actually need the repository to be mocked. Yeah, I'm going back to my notes because again, I'm drawing a blank on some of this stuff, and I'm just yeah, controller and service should be in there. Okay, so we should let's try this again. Oh, look at that. Okay, yeah, so I'm losing my mind, but at least it's not completely gone. Okay, so let's go ahead and do another one here. Let's do our by ID, step verifier dot with virtual time. Again, we'll do our client dot get dot URI. In this case, we're accessing coffee / ID. Come on, there we go. And providing our coffee dot get ID here. Okay, dot exchange dot return result. So in this case, it's a coffee once again. And then get response body. And we'll take, once again, 1 because we know in this case it's a mono. Actually, all of these are returning initially a mono of server response, which, again, I'll show you that as we go as well. So we know in this case, even though we're getting a flux of 1 and a mono of 1, they're actually wrapped in a mono server response. So we'll do an expect next. We should get our coffee back as we expected. Verify complete. And let's run that. Oh, so it should. Almost. You were almost there. You caught me before I hit it. So let's see. Let's do that. Let's run that. Okay, so we passed that test. Now, just so you know, there's no funny business going on. New coffee, bad coffee. Okay, so now if we run this again, this should fail. Again, I just like to make sure my stuff is failing when it's supposed to and not failing when it's not. Okay, so coffee. Okay, so, and I've already mentioned that we know that this is going to give us some problems because it's not going to pass things through with our server sync events. I'm going to comment this and we'll come back to it later if we have time. I'm going to just go ahead and run and make sure all of our tests work here for our external API that we need to verify and test, and everything works. Okay, so let's go ahead and charge on here and expand this a bit. Let's see, what do I want to do? Oh, let's do security. That's always exciting too. That's almost as exciting as tests, right? Everybody's like, oh gosh, make it stop. This is why I don't list tests as my first bullet point. Well, actually, ironically, tests and security. I always kind of half-jokingly say that, is everybody familiar with the company named Equifax? Yes, okay. I always lean heavily on our Spring Security folks because I could be literally the next Equifax. I don't trust myself security-wise. I'm not that great at testing either, but security is the other thing. So why not just show all the bad stuff, right? The stuff that, for me, I'm horrible at. So let's bring this back, and let's work in some security. So let's see. We need to make sure that we can secure our endpoints. So yeah, let's go here. Let's do enable WebFlux security, and I'm going to create a configuration class. So I can create some beans. So security, config. So I'm going to need some way of doing authentication and authorization, right? So I'm going to create a bean. So let's see. Actually, I want to do my authentication first. So I'm going to authenticate. Yeah. So let's see. What do we want to do? First thing I want to do is create some users. User details. Let's see. I'll use me as a bad example because, as a colleague of mine likes to say, you're not totally useless. You can always serve as a bad example, right? I'm going to use the default password encoder. This has been deprecated for all but demos because the idea is, of course, in a properly secured system, you're actually loading and storing and retrieving these credentials. You're not making them up in your application, but again, for the purposes of the demo, I'm going to go with that. I'm going to create a username, Mark, password, bad password. This is what I do for everything, so you could even unlock my Mac if you just type this in. I'm kidding. I'm kidding. Wow, please don't do that. So on roles, I'm going to call myself a user because all users are inherently insecure, right? I'm going to build that. Okay, so I need actually another one. User details. I'm going to use Rob Winch. Rob is the head of Spring Security. Rob is inherently secure, unlike me, so I'll go with that. And I'll use, again, the default password encoder, username, Rob, password, and we'll make this better password. Yeah, well, okay, so this is not Rob's password, obviously. I'm going to give him the roles of user and admin, because I don't trust myself with admin for good reason. Okay, so let's see. So we need to now return new map reactive user detail service, passing in Mark and Rob, and that gets their authentication. So that will verify that only we can access this, at least at this point in time. So the next thing I need to do is provide some means of authorizing. So I'm going to add in a security web filter chain. I'm going to create an entry here. We'll call this authorization, and I need to, let's see, let's shorten that. Make this a little nicer. And let's see, what do we need to do? Return HTTP dot basic and let's authorize exchange, any exchange in which the user has the role admin. Let's just lock me out entirely, right? Because that seems actually like the safest thing to do. So let's see. Oh yeah, actually I'm going to just do this and build. Okay, so that's rather simple, right? But if you go and plumb the depths of Spring Security, you will see that we are retrieving, we are passing publishers back and forth. We have actual honest-to-goodness publishers. We're actually subscribing. So we are doing things reactively. We're not just blocking on a thread and waiting. So let's go ahead and run this. And let's see if I've sufficiently locked myself out. That's a good thing, right? That is the affirmative. Okay, so we're back up and running. So let's go out here and do some testing. HTTP. Let's see, this is Cassandra, right? Coffees. Okay, so I'm unauthorized. Well, it's unauthorized to access this without any kind of credentials. So what I'm going to do is provide auth. Let's try it. Mark, bad, password. Oh, bass password. Okay, well that actually is just the same. So we see that we're forbidden. I am forbidden to access this data, which again is a good thing. So I'm going to pose as Rob. Since Rob's not here, he won't mind too much, I don't think. Better password. Exclamation, right? Yes. Okay, look at that. So that all works. Yes. So that's fine. So maybe today I won't be the next Equifax. That's good news. One thing I actually forgot to show you earlier, which was kind of a shame, but we'll fix that now. So if I go to localhost 8083, right? Actuator. Oh, yes, I've secured actuator, at least at a very crude level at this point. So better password, unless I miskeyed. Nope, that's good. Okay, so let's blow that up where it's a little more visible. So we see that actuator does expose quite a bit of information. This is good, and this, by the way, works in a blocking or non-blocking mode. That's good. So if you're using Spring MVC, you can still use actuator. If you're using Spring Webflux, that's great. You can still use actuator. But how do you know, right? How do you know this is dealing with publishers? Well, let's go to our mappings. Look at that. Okay, so publisher. Look at that. So we have publishers throughout. So this is fully reactive where, no blocking. So that's kind of nice. That's just a little aside. I like to show it because I think a lot of people who have used Actuator in the past don't want to leave that behind. You don't have to. Those who haven't used Actuator, check it out. It gives you a lot of control. By the way, that is also fed now by Micrometer.io, which is a new project of ours. We have a former Netflixer who came out and came over to our team and is developing Micrometer.io to be the SLF for J for metrics. So it works with a lot of different suppliers and deals up some very, very nice metrics. Actuator is based on that as well with Actuator 2.0. So kind of a nice little extra. So let's see. I do want to, this is the updated time, right? So I have all this time? All right, good, because we'll need it. Okay, so the next thing I want to do is to change things up a little bit, because so far what I've done is talk a lot about what if you're coming from a Spring MVC world. Oh, actually, I kind of skipped blithely over debugging. Let's go back and do debugging. See, this is why I consult my cheat sheet to make sure I don't skip over. Debugging. In imperative code, you have a call stack, which, although we all cringe when we see them, it actually gives you some meaningful trace information, right? It's some meaningful reference information for how you got here and where to go back and work through to try to find, isolate, and fix the issue. When you have non-blocking code, that becomes a little more problematic. I'm going to create an endpoint which will throw us some nice, beautiful errors here. So let's see. I'm going to just, let's do this. Get mapping / debug. Debug, okay. So let's see. Public flux coffee, get coffees, and error. A site of error. Okay, so we'll return service.all, but we'll also concat with mono.error. We'll create a new throwable. Let's see. I've got a bad feeling about this. With solo coming out shortly, why not, right? Okay, so this, we're going to concatenate this. I'm going to clean this up just a little bit. Okay, so that's all right, right? So let's go ahead and restart this, and let's see what kind of a wonderful mess we get when we call that. Okay, clear HTTP 8083 coffees debug. Boom. Oh, whoops. I'm secured. Gosh, this is why I don't like to do security right off the bat. Okay, so let's see. Let's do a --auth. Thank you, Rob. Better password. Boom. Oh, yeah, look at that. Okay, see, we're getting the proper error, so that's semi-good, right? So let's go back and look at our call stack. Oh, boy, that's helpful. Okay, so the good news is, I guess at least to some degree, and we have very simple examples, so we only have a couple lines. Yeah, it's not horrible to try to trace through. You wait till you create this really long stream of operators, and then you subscribe to it from another place, and it doesn't always match up well, right? So here's what we get. So we see that we've got a Java lang throwable. I've got a bad feeling about this. We see that it's actually at line 101. So let's go back and go to line 101. Yeah, so there it is. So it's starting off with our return, okay? And that's semi-useful, right? But again, we have a very simple example. So imagine if you had several operators, and if, again, you're calling this from several different places, this gets to be a little trickier to debug. The good news is there are several things that you can do to make your life a lot simpler. So I'm going to use hooks and on-operator debug. Now this is not free, right? This has a little bit of a performance penalty because, again, you're tracking all of these call stacks as you issue a call, as you subscribe to a publisher. So this is not something you typically leave you litter your code with throughout before you create in any publisher. but it does give you an idea of what you can get here. So we're going to do this once again. We get the same error, but now we have a little bit more useful information. So we can see that the error has been observed by the following operators. Well, I guess let me start at the top again. So you still, too far, not that top. So you still get your error here, and you still see that it's showing 103. The difference is, I guess to start with, is that now you're at the, well, no, actually it isn't. Never mind, carry on. So when you get to, I'm skipping ahead of myself again. So when you get down to the end and you take a look here, you can see what operators have actually dealt with this error, have seen this error. So you've got your mono error, kind of makes sense, your flux concat with, and collect list. So you see that these are the operators that are affected or have visibility into this particular error. So again, this is not for free, but it gives you a lot of visibility and insight if you have a easily reproducible problem. Now, I'm going to remove this. And by the way, to remove this, normally you just do a hooks dot reset on operator debug. So I mean, that's the converse of that if you want to, again, bookend your code that way. But you also have the ability to do things like insert checkpoints. So I'm going to insert a light checkpoint at this point. So I'm just going to say checkpoint B. We'll say B because I'm going to insert another one earlier here in a little bit. And actually, just to go good and crazy here, because why not, right? So let's return a mono dot, and we'll make this of type coffee, error. This is a bad one. Okay, and then we will do a concat with, let's see, service all, there, that's better. Okay. So let's just go really crazy, right? And instead of doing this right here, I'm going to, dot checkpoint again here, and this will be our checkpoint A. So this gives us a little bit more visibility. Let's go ahead and run this. We're inserting an error right off the top, and then we're grabbing all of our values and we're inserting an error at the end. Why not? Again, it's good, clean fun. Oh, let's see, cannot be converted to, oh, whoops, no, got excited and just completely omitted the throwable there. Oh, it's exciting, isn't it? The tension, you can cut it with a knife. Okay, so I know I need to get out more. Okay, so we've got a bad one. That's good, right? So let's blow this up just a little bit. So we see that the error has been observed by the following operator. Oh, no. You know, that's not terribly helpful, but it does show we have a light checkpoint here. Actually, let me zoom in on that a little bit. Is identified by light checkpoint, checkpoint A, description, checkpoint A, okay? So that's actually pretty helpful, but it doesn't give us our nice stack trace like we would want to use. So if you really do need that as well, you can throw this in, and that forces the stack trace. I'll go ahead and restart this and take a look at what happens when I do that. Okay, so let's try it again. Ooh, bad one. Okay, so not only do you get your, go back up here. Yep. So you get your light checkpoint here, a checkpoint, or it's not a light checkpoint anymore, I should say. It's described as checkpoint A. You get your assembly trace, and then you can see once again where it has been observed. Now in this case, we've got an early checkpoint right after an error, so we don't get quite as much information. But if we pull that out again and just go back to our service all, that should be good. And then let me add this in here so we can kind of see what's happening there. Okay. And I just realized we've got a second break here we need to take really quickly. So we'll try to actually compress that break just a little bit once we do this. And now we can see that, again, we've got our checkpoint. It's been observed by our checkpoint. And if we go back up to the top, then of course we can see, oh, I didn't go up to the top yet. We can see, of course, that we have our throwable that we expected. There we go. Okay. So it gives you a lot of different levers you can pull. So you can do your hooks on operator debug. You can set light checkpoints. You can set checkpoints that allow you to get a full stack trace in addition to the checkpoint. If you have a lot of publishers that you're creating throughout your code, which chances are you're going to, it depends on what your needs are, how heavily you want to instrument that, how heavily you want to add to the burden of that, so to speak. So really quickly, let's go ahead and take maybe a 10-minute break. Can we do that? And then we'll come back and we'll just wrap everything up and go through, and I'll show how to do things functionally as well, and then maybe a little bit of Kotlin, and then we'll take Q&A. I just chugged some coffee, so now I need to drink some water to get the throat clear again. Okay, so far everything's working, but we can fix that. It's okay. We can break this. I was talking over break with somebody here, and we were talking about the differences, the compare and contrast with the annotations based approach versus a more functional reactive type of approach. I'm going to show you a way to do that now, just if you're coming from a more functional reactive type of background and less of a Spring MVC background. The REST controller request mapping, this type of thing may not seem as maybe ingrained. So let's change things up a little bit. I'm going to just comment that out, and let's define our routes. Now, I'm going to actually, just to save myself a little bit of time, I'm going to create a routing bean here, and I'm just going to change my security config class, because really I'm going to just do a little more configuration in there, so I'm just going to rename that. Because again, I've got a configuration class, which in Spring allows you to define methods that return a bean to contribute to your bean bucket. I want to do just that and create a bean for our routing. So a router function of type server response routes. So now, there are different ways you can do this. Actually, since I've got a little bit of time, I'd kind of like to show you maybe all three of them, which that would be awesome. Well, I showed you one actually already with the annotation, so just a couple of them here. So we can define our routes functionally. So we can do a return router functions dot route, and we can define our routes this way. Now, we need a request predicate to start off with. I'm going to do a get. Again, we start with our coffees endpoint. That's the simplest, so we'll start there. Now, this actually takes a handler function. Handler function is a functional interface with a single abstract method. So we could do this. We can create an anonymous inner class, but since Java 8, that looks really, really ugly, and just part of me wants to hurl when I see this. So there are better ways, obviously. Since Java 8, if you have a functional interface with a single abstract method, what can you replace that with? A lambda, right? Makes it nice and neat. So actually, I'm going to just show you one thing here. So we can do this and just replace this with a lambda, something along the lines of this, right? So we take a server request and we do something with it. So what I can do is embed this directly this way. I can do because what we're expecting to get back is a mono of server response, right? I mean, we already see this. We're getting server responses back. So what I can do is do a server response dot OK. And then I can create my body here. Now, I actually do need to get to something, right? So I'll use my internal API here. So coffee service. We'll just shorten that. So I can create my service dot all, which returns objects of type coffee, right? And that is sufficient. And then if I want to go ahead and do another route, I do an AND route, and I declare them all this way. Now that works, but it tends to get a little verbose. I know some people like that because it keeps things all nice and tight in there. I don't like that as much. Again, I think that's a matter of preference, right? But what we need to do is just define a handler that we can use for our handler method. So I'm going to just go up here and create another component called a coffee handler. And let's see, private, final, I'm going to once again use our coffee service internal API. That's fine. Actually, I'm going to shorten that because, again, space. And we'll inject that. And then what I need is, this. This is a signature I need right here. So I need to return a mono of server response. It is a mono because it is one response, right? Even though we may have a flux in there. It's flux stuff. Anyway. Okay, so we know we're going to be accepting a server request. We're going to be returning a mono of server response. So we can do something with it. In this case, I'll make the all method. And again, we can just do a service dot, actually I need to do a server response dot OK dot body. Service dot all, once again, coffee dot class, and that's it, right? So that's our one handler method for all. This has the added advantage is it separates your routing from your handlers. So that's kind of nice. So now I just need to blow this out a little bit and do a couple more, because we know we've also defined a by ID path where we can retrieve a mono of type coffee, and then we also want to return our orders. So they all have a very similar footprint, similar signature, but instead, of course, here we're going to do a service dot by ID. We're going to take our request and extract our path variable out of there for our ID and return a coffee. Again, pretty simple. This is a little bit different because instead of doing a service.all, we need to do a service.orders. Once again, extracting our path variable for our ID. We're returning a coffee order in this case, right? Or a stream of coffee orders. The other thing we need to do is somehow indicate that this is not just a bunch of JSON in a single document. So we need to indicate that the content type is similar to how we did with our annotation-driven approach, dot text event stream. So now that we have our handler methods and our handler bean, we can, oops, back below here, instead of injecting our service, we can inject our handler. So now we can do a handler all. And that's our route, right? And then we can do an and route, request predicates dot get / coffees / ID, and then once again handler by ID, and then finally and route request predicates dot get / coffees / ID / orders, and handler orders. Okay, so that's not horrible. We can do a little bit better with this, though. We can use some static imports and shorten things dramatically without losing any readability. So that looks pretty good, right? So now, yeah, much better. So let's go ahead and rerun that and see if I've broken anything here. Oh, and I have. Oh, it's our test, and that's good, right? Because now we no longer have a coffee controller, so we really, what we need to do here, is there anything we need to insert here? Yeah, coffee, actually we need to do our, router functions.class, get it right here in a moment, and then, no, actually it's not router functions, it's router function. Yes. And then we also need to include our coffee handler class. And then here, let's see. Actually, I should be able to do that, right? Hold on. Test failed. Oh, I actually need to, so that should be, do I have the controller in here? No, I don't. Okay, so coffee handler. Don't think that's right. Instinctively, I don't think that's right. No, it's not. Okay. Router function. No. Shouldn't need to. You should be able to do this. So the router function .class coffee handler, because I need my coffee handler. Always need the coffee handler, right? Coffee service. Where are my test gods here? So I need this, I need this. Should be coffee handler. So let's double check this. What am I missing? See where it yells at me. Well, I will come back to this because I don't want to just spend all the time debugging, so I'm going to do something very, very bad here. Oh. Oh boy, let's see. All right, don't do this at home. Okay, so I will come back to this. The show must go on. Okay, so we're back up and running. Let's see if I did anything right with this. Okay, so we've got our coffees, and that all works. Okay, so let's grab an ID. So let's see, we'll do our Dear Green Place Cassandra. That all works. So now let's get our orders. And I actually do need to do a -s. Okay. Okay, so everything works. My testing, as usual, is lacking. So don't tell anyone. Okay, so we've got everything back up and working, including defining things, our routes functionally, versus with a more standard, more typical REST controllers. There isn't really a wrong answer with this. I mean, do what makes you happy, do what makes you more comfortable. Personally, I lean toward the REST controllers because I think you'll see a lot of that in the wild, and I think it, again, reduces that cognitive load when you task switch. But if you prefer this, that's great. It's fine. You're not running afoul of anything, so by all means, go forth and functionally route. Let's see. We've done the route. Oh, I do need to show you the web client because, again, how will you create another independent microservice that can then access our backing service, if you will? Because right now we've got our coffee service. We need to perhaps provide some kind of a front-end type of application or another consuming microservice that provides other functionality but still references and leans on our coffee service to provide that capability. So let me go ahead and do a client here really quickly. Actually, we'll just call it coffee client. We don't need any kind of data storage. Again, we have our backing service for that. Yeah, that's cool. So we'll include that. Sure. Probably fine. So let's go ahead and open that up. Open. And let's see, this will be another service. We're going to run this, let's say 8090, just to make sure we have no port conflicts. Port conflicts are a real bummer. So we'll go here. I'm going to, once again, I'm going to create my domain. Let's see, so coffee, private string ID, and name, right? Okay, at data, at noargs constructor, at allargs constructor, and then once again we have our class for coffee orders, coffee order, private string name, no, ID, coffee ID, and private date. Date ordered. And again, at data, at noargs constructor, at allargs constructor. Okay, so let's see. Let's just shortcut this just a little bit. I'm going to create a bean here for our web client. So client return web client dot, and since I'm using security, I need to use the builder. I can't take the shortcut of just creating a standard run-of-the-mill web client. That's a good thing, right? I mean, security is a good thing. So we're going to leverage our builder, and I'm going to, let's see, use the base URL of http://local host 8083, right? Coffees, that's our base URL. And then we need to have a filter, so we can have an exchange filter function for basic authentication. And we need to provide a username. We've already seen that I'm locked out. Again, a good thing. So we'll have Rob use Rob's credentials. In this case, this is, again, we're cheating a little bit. We're cutting a corner because you're not going to embed somebody's credentials in another microservice. But again, we'll accept that trade-off just in the interest of time. So better password. Okay, so that should be good enough to build our web client. So, and actually, let's just do this. So component, we'll just be consistent. Class, demo, nope. Private, final, web client, client. Okay, post construct, private, void, run. Just sounds dynamic, right? Okay, so we're going to do a client.get, right? We don't have to specify a URI because for starters, we're just going to grab our coffees. We're going to get our coffees and just particularly grab one of them that we can turn around and use. So we're just going to do a retrieve. And then we're going to do a body to flux, so we convert what we're getting back directly to a flux of objects, in this case, coffee objects, right? And then we'll do a filter so that we can filter out our coffee that we want. So coffee dot get name dot equals ignore case. So which coffee do you want? Nobody cares, huh? How about dear? Oh, this is Couchbase. We'll have to change that. Let's see. We don't care. Let's see. Oh, there's the client right there. There it was. Back. Okay. Nope. Client. Okay. So this will be Cassandra. Well, we don't care about case. So so you can see, it's real. Nothing spontaneous whatsoever. Okay. So we've got our filter. Let's flat map that coffee, and let's access our client again and do a get. And this time we need to specify our URI, right? In this case, we'll add on and reference our ID and our orders, right? And use our coffee get ID so we can specify which orders we care about at this point. And then we'll retrieve. And then we'll convert that body to a flux. In this case, they're coffee orders, right? And then let's subscribe. And again, because I like to see what's happening, let's verify what is actually happening. So, should work, right? Very neat, very tidy. Let's run it. Look at that. Okay. Oh, we're getting a date of null. So obviously something is not quite right. So we've got a date ordered. Let's see. Redis, couch. Now it's stuck. Oh, IntelliJ, you're killing me. Okay, so we'll go back to Cassandra. Oh, it is. Oh my goodness. Okay, so that's just embarrassing. So. Yeah, I can't blame it on Lombok. Sorry, it's just me. All right, so good catch. Actually, I was sometimes it's kind of hard to spot that when everything your eyes just right past. So let's find out here. Now let's see what we have. It's so close. Okay, look at that. That looks much nicer. Okay, so we're getting a value every second, which is exactly what our flux is producing, so we know everything is working. so that's not too bad. So let's see. We have time. Let's see. I want to see if there's anything else that I want to do before I launch into this other. There are two things I would really love to do if I have time. Oh, we do. Awesome. Okay, Kotlin. Where are my Kotlin people? Yeah. So this is a pretty simple example, admittedly, but I like to show it because as of Spring Framework 5 came out last fall, like I said, 1 week after Java 9. There were three big stories to that. One is Project Reactor, the full reactive capabilities. Another was Java 8 baseline because Spring Framework 4.3 and before baselined on Java 6. I like to say that we supported that even when Oracle quit. But with with Spring Framework 5, we rebaselined on Java 8 because, again, it's over 3 years old. And it kind of made sense because that way we can take advantage of the goodies like the completable futures and the streams and the lambdas and things like that. But the third thing that was big news with Spring Framework 5 is full first-class support for Kotlin. For those of you who haven't, yeah, all right, yeah, exactly. For those of you who haven't used Kotlin, why? I'm kidding. It's, I mean, there always comes a struggle, right? I mean, do you get better at your one primary language, or do you kind of like dally with others, I think Kotlin is, as I mentioned earlier, I consider it like Java++. I think you'll see things coming into Kotlin with a bit more alacrity. You have the designers, the architects of Kotlin who are doing things, they have a little more free hand, right? Java, for better and worse, primarily better though, frankly, has been very, very, very rigorous about backwards compatibility, at least till 9. So they haven't always had quite the free hand to insert capabilities into the language. Kotlin is much younger, much newer, and it's still very much largely controlled by one group. So I don't think they're reckless at all. Please don't misunderstand my saying this, but they do have a little more latitude to implement capabilities that maybe the Java architects don't. The good news is that there's a lot of cross-pollination in all languages, right? But especially within JVM languages. So you see things that are coming into Kotlin that people try and they use and they like and they start kind of requesting / demanding out of Java. So you're seeing things in let's see, I can't remember all the clever names like Project Amber and Project Valhalla and Project. So you see some things that are coming in that have either been inspired by Kotlin or at least strongly validated by Kotlin. So I think it's a good language to get under your belt. I actually do a talk about springing into Kotlin where you can convert existing brownfield Java-based Spring applications to Kotlin, and it's pretty painless. So you can have both in the same application, or you can go straight greenfield. I'm going to go straight greenfield here today, but again, these are fairly small examples, so it won't take us long to do that. But whatever you have, you'll find, I think, that Kotlin works pretty well with it. So let's create a coffee service in Kotlin. I'm going to, of course, choose Kotlin right there. Yay, right? Yay for Kotlin. All right. Okay, so we need to, let's see, I'm gonna replace Mongo. Mongo's had a hard day. Let's replace Mongo. I really don't need actuator security in that, so pull those out. Oh, Lombok, we don't need that either. Good catch. Yeah. All right. So, okay, so let's go out here. Kotlin. And let's open that. And while we're opening that, I'm going to go over here and kill Mongo. What, no cheers? Kill Mongo! Oh, okay. It's all right, we'll bring it back. Okay, so let's see. Kotlin, maximize. Let's see, let's go to our application properties. We were running Mongo on 8082, right? Right? Yes? Confirmation? Cool. Okay. Okay, so our main application. So let's see, where do we start? Well, we start first with our domain, right? So class, coffee, and actually before I get into this, with Kotlin, I don't want to go too far down the rabbit trail here, but for those of you who aren't, for the vast majority of you who aren't using Kotlin, with Kotlin you typically don't have to define a lot of constructors as you sometimes do in Java. you can typically use a primary constructor. Sometimes, and you can do other constructors as well, but usually you can get by with a single constructor with a few different clever features built into Kotlin. So you can do this, constructor, and you can put the constructor, the primary constructor, right in the header. You don't even have to do this. You can actually omit constructor and just put your arguments here. So for instance, with Kotlin, let's see, where do I want to start with this? We have an ID field, right? Or an ID annotation, because if you remember what we had the ID field annotated. And then we have, let's see, a val. You can define things that are like effectively final in Java. So you have final variables. You can just define them as val, so they can be assigned once, immutable, if you will. You can create vars, variables that can be mutable and assigned multiple times. We want this to be assigned literally once, and that's it, one and done. So this is our ID. We list the field name first, and then, or the property, if you will, and then the type. Now, I could make this nullable. I'm not going to. I don't want a null ID. I want it to be required when we create each coffee. But we can also assign default values. So that's why you can get away with a single constructor most of the time in Kotlin. I'm not going to do that because I'm going to be just providing that each time, so on and so forth. So the other thing that we want to do is create, once again, our name. And we don't have getters and setters and member variables. We have properties in Kotlin. It's, again, very similar concept. Read up on it. I think you'll find you like it. So here we go. And again, this is a document class. And this gets most of what Lombok had, right? But Lombok gave us the ability with the @data annotation to have a data class where you had your getters and setters, your equals hash code and toString. Well, baked into the language, Kotlin has the concept of a data class. It's just so easy. If you don't have to do anything else, you literally can stop right there. That's your entire class. So it's pretty slick. Okay, this isn't a Kotlin class. Sorry, I get excited sometimes. I get a little off the beaten path. So okay, so we need to create our interface for our repository, right? Coffee repository, and this is how we indicate implements or extends, right? With just a single colon. So reactive cred repository for coffee. Object specified coffee. ID is a type string. Again, don't even need this. So nice. So let's see, what are we lacking here? Well, just our bean, right? So let's see, we have a component class data loader, right? We had a data loader. So let's see. Oh, we actually want to inject, if you remember, via constructor injection, our repository. So this is very easily done. I'm going to declare this private, val repo coffee repository. The reason I do this is because if you don't have that private visibility modifier, it's public. And we don't need to access a repository from within our data loader externally to our data loader. We don't need to expose that from our data loader. We already have it. It's a bean. It's accessible within our application. So we make it private visibility within our data loader itself. So now we can do an @post construct. Okay, and in Kotlin, there are no methods, they're functions. Everything is fun in Kotlin. Yeah, so we'll create a load class, load method, excuse me. I know it's been a long day, stick with me here. Okay, so let's do this. The rest is very similar, of course. We do a repo dot delete all dot then many. Let's see, and we do a flux dot just, actually, you know what, I'm just going to copy this. So let's go back to our Mongo. There we go. And we'll grab, actually, I'm not going to go quite that far. Let's just grab that. Okay. Yes, and this is another nice thing about IntelliJ. I'm sure the other IDEs will be coming soon. If you do copy in Java code, it says, hey, I noticed you're copying in Java code. Do you want to try to convert this to Kotlin? Sure. And actually, that's pretty easily done here. I mean, that's not much difference. So we have our flux of just these values. And Where am I? Where did it go? Oh, come on, IntelliJ, you're messing with me again. I've lost my mouse. There we go. It's back. I find if you just Alt-Tab or Command-Tab, in this case, to another window and come back, that at least restores that particular interesting capability. Okay, with Kotlin, instead of doing a map with parens and a lambda, you can just omit the parens, so that cleans things up just a little bit. You also don't have a new keyword for constructors, so I can just do coffee, coffee, and let's see, I want to pass in the name as a parameter, but I also want to create my ID again, so UID random toString, and then we could, with our lambda, do a name like this and pass that in here. But there's really no need, because if you don't specify the parameter for a lambda, it's just it. Cleans things up a little bit. And then we flat map, so we take our coffee value and we do a repo save, and then we'll do a then many. No, let's see. Oh, of course, I forgot to close that out. And then we'll do another then many, so we can do a repo find, oh, I should say dot find all, and then subscribe. Why are you doing this to me? Subscribe. And then print line it. I'm sorry?
Repo method reference save is broken.
Oh, so it is.
Okay, so
Oh, that's interesting. Okay, so repo.save it. Wow. Okay, so we're off and running. So let's see. Oh, we need to create our endpoints. Yes. Okay. So once again, REST controller class coffee controller. Oh, let's see. So private val repo. Boom. Okay. So at get mapping, and this was pretty simple. We just did a /coffees fun. Let's see, what are we going to call this? All, right? And again, another nice thing about Kotlin is if you just have a single statement, you can just do a direct assignment. So that's kind of sweet. Repo dot find all. And notice, no semicolons. That's my hardest thing, switching back and forth, is just shifting the brain to add semicolons, remove semicolons. Really, I know, tough life. Okay, so we should have everything we need, right? So let's go ahead and run this. And off we go. We see that it looks like it's persisting everything correctly. So if we go out here and do an HTTP 8082/coffees, and there we go. So again, pretty simple stuff. Let's see, what else? One thing that I like to do, I do have enough time, I think, to squeeze this in without adversely impacting our Q&A. So what I kind of like to do is show a chained endpoint, because as Dr. Sheldon Cooper likes to say, what's life without whimsy, right? So you've already seen the web client, so I'm going to actually just, I've never tried incorporating this with the Kotlin one, so this could be fun. This might not work. Are you ready? Okay, this is cool. If it doesn't work, you can help me fix it. Okay, so the Redis we're going to leave in place, so that's cool. Couchbase, we're going to create another endpoint that allows us to grab our Redis coffees and pass them on as a client, as a consumer. Right now, each one of our reactive services are publishers, are producers, but they're not consumers at all. No, none of them. So let's fix that. We can add some things here. I don't have any configuration class, so I'll just throw it in up here. That's fine. Let's do an @bean, web, client, return web client dot create, and we're going to access our localhost 8080/coffees. So we're going to grab our coffees, right, from our Redis service. Let's see. Let's go here and let's add an endpoint here. Oh, actually, I do need to inject my web client. Private final web client inject. Okay, so let's just add this at get mapping / upstream. Okay, so we're going to get our coffees from upstream. Public flux coffee upstream. Return. Let's see, client dot get dot retrieve dot body to flux coffee class dot. Actually, that should be it. Okay, so yeah, that should work, right? So let's see. Let's restart this. And actually, no, I need to indicate that this produces media type dot text event stream value. Okay, so this should be fine, probably fine. Okay, so that all works, at least to this point. So let's go ahead and restart this. And let's go for broke. Let's just copy paste it across them all. So we have to fix it multiple times if it's broken. Okay, so Mongo. No, we've killed Mongo. We're going with the Mongo. Hello, IntelliJ. We're going with our coffee service Kotlin. So let's see. We want to create another bean. So shortcut here. And look at that. Hey, do you want to convert this to Kotlin code? Sure, please do. Okay, so let's see. So, and I've lost my cursor. There we go. Private val client web client, right? Should work. Okay. At get mapping / upstream produces media type dot text event stream value, and in this case I need to add array of. It's just a Kotlin idiosyncrasy with syncrasy. I can't even talk now with our mappings. So let's see, fun upstream equals let's see, actually client dot get dot retrieve dot body to flux coffee dot, oh actually Kotlin. Yes, look at that. Come on, there we go. And that should be it, right? So let's go ahead and restart that. And since I can't very well copy paste that quite as nicely, let's go back to our Couchbase. That all is working. So now let's go to Cassandra. And since I have a configuration class, I'll just drop this in here. Okay. And then go back to my, nope, not Mongo, Couchbase. And I will grab this. Cassandra. Oh, we have our other route. That's fine. Well, thanks. Well, actually, oh, why not? Let's just do this. Let's do it. Let's do it with our functional reactive routing too. Why not? Okay, so public mono server response. Upstream server request return server response. Boy, we're going for broke here. Okay, dot content type media type dot text event stream dot body. Oh, yes. Okay, so Why not? Client.get dot. Come on. Let's see. Yuri slash. Oh, wait a minute. No, I'm already defining the Yuri. I don't have to do this. Retrieve dot body to flux coffee dot class, and of course that returns a coffee dot class. Sure seems like it ought to work, right? Okay, so let's restart that, see if I've missed anything, and then assuming that works, let's tie them all together. Okay, so in theory at least, and if not, we'll always think it should have. Okay, so HTTP:8083, which is our ending one, right? Coffee, oh, it's actually, yeah, coffee's upstream. So what should happen is our Cassandra service should make a request of our Mongo Kotlin service, which should make a request of our Couchbase service, which should make a request of our Redis service to provide these coffees, which will, by the way, be doled out at the rate of 1 per second from our Redis service. Oh, I forgot. Security, whatever. Okay, auth, Rob, better, password. Oh, it's still not happy. Okay, so it's saying okay. Okay. So, first one to find it, I don't have a t-shirt, but I will offer my hearty congratulations. Okay. What's that? Yeah. Oh gosh, yes. That would help, wouldn't it? Okay, so let's see. I did all the stuff except for the bringing it together stuff. So that doesn't count. So get slash coffees slash just upstream. Come on. Handler. Sure. That'll work. All right. So who said that? Awesome. Come see me afterward. Like I said, I have nothing to give, but thank you. makes the demo go a lot better when things work. I don't know why. Okay. Oh. Well, that didn't do it. Okay, so let's see. All right. So coffee's upstream. Yeah. I'm authenticating with Rob Better Password. It doesn't need to. Nothing else is secured except for my Cassandra service. Well, I have to wonder if my Kotlin service is. Well, you know what? I'm just going to just radically simplify things, and we'll just. What's that? I threw it down here in my configuration. Oh, it is, isn't it? Oh, dear. All right. Well, this might help. Okay, so that's my Cassandra. Oh, you're right. Wow. What? Where are the rest of you when I need you? Front row, please. You're killing me. Okay, so, yeah, I know. It's my bad. All right, so let's restart. What's that? Oh, forgot the coffees, didn't I? Yeah, I'm still leaving stuff out. Coffees slash. Okay. This really is fun when it works. Okay, so let's go to the coffee service Kotlin. Let's go to where we defined that. And there it is again. Look at that. So that should go back to 8081, right, for our Couchbase. So let's redo that. And then let's go to Couchbase. Shutter. Okay, and Couchbase actually should go. No, actually Couchbase should go back to Redis. So that's why it should be there. Right. Okay, so that's cool. So let's just start the party. Now let's see what we have. This should work, don't you think? Bets? Anyone? Oh, you're killing me, Smalls. You're killing me. Okay. All right. So let's simplify things just a little bit. Let's just go back to clear HTTP:8081, right? Upstream. Oh, oops. I forgot to do the -s. Well, at least we'll know if it works. Oh, you're. Oh. I think I may have found an issue here. Oh, no, actually, no. Wow, okay, well, let's take a look here. We got some wildly inconsistent stuff. All right, so we'll go back to our Couchbase. Couchbase we have defined. Oh, and see, yeah, with Cassandra, we did that differently, didn't we? Yeah, because that's when I broke everything out and added rigor. Rigor breaks everything. Okay, so right now we know that for our Redis, we just had one endpoint defined, coffees. Now we have just upstream for Couchbase, because with Redis, it just has the /coffees. That's what we're accessing. So this is all very, very simple. So now if we go to, Kotlin, that's our Mongo. That's our Mongo bogey. So we know that this is just upstream for Couchbase. Let's go ahead and run this. This is what happens when you build out examples and then forgot you build out examples. Okay, so Mongo should be up and running, so let's find out. Let's hit 8082 upstream. No, it's just /upstream. No, this is 2. Did I do? No, I did 1. Wow. Well, see, this is my first time with inserting Kotlin in the middle of things. But it shouldn't matter. I mean, this is, Okay, so Kotlin application, upstream. Run that by me again.
So I don't know if this is a Kotlin thing or not, but the producers for upstream is text event stream value, and all the rest of them are just text event stream.
Actually, in the when you list it, let's see, with Couchbase even. Oh, you know what? Text stream value. Yeah, it's you switch it to the actual type instead of the string when you're using the functional routing. That's where you've seen it. So, okay, so that all looks right. Well, okay, so that was anticlimactic. So now I have something to work on tonight, so that's cool. Yeah, this is going to drive me a little crazy now. But the Mongo stuff is where it's where it all stops. It's not found. So where's my routing in Mongo? Oh, this isn't. Sorry. Coffee service Kotlin. Get mapping, upstream. I don't know. Just seems like it ought to work. Something's obviously not happy. Localhost 8081 upstream. Okay. Well, anyway, that'll give me something fun to research. If you follow me on Twitter, I'll tell you what I did wrong and that we're all overlooking somehow. And again, this isn't rocket surgery, so I'm not sure why that's not working. Okay, so let's go back, wrap things up, and then we'll take Q&A because we still have about 9 minutes left. So some helpful resources. The Reactive Streams initiative has a site called reactive-streams.org, which gives you a lot of the background as well as the details behind/within the Reactive Streams initiative, the players, the line of thinking, where it was going, where it originated. It's a good resource site. ProjectReactor.io is the site for Project Reactor. Makes sense. By the way, I didn't really make this clear, I don't think, but you don't have to use Spring to use Project Reactor. It's a dependency of Spring, not the other way around. But obviously, who wouldn't want to use Spring, right? But Project Reactor is a separate library. You're welcome to use it in anything. All this stuff, I should have mentioned this right off the bat, all this stuff is open source. Everything that I showed you and more is open source. Even the Spring Spring Initializer is open source. Sometimes people say, well, my company will never let me have access to all those libraries. They control what we get to. That's fine. It's open source. You can fork it. You can create your own version of the Spring Initializer, as much as that makes me cringe and cry to say that, with the libraries that you have access to within your company. So everything 100% is open source, and we develop in the round. So we put everything out from day one on GitHub. It's something that I'm kind of proud of. I love that companies will open source stuff, but it's a little frustrating to me when they work on something 2 or 3 years and then they go dump it and it's open source. And that's better than not, right? But even from day one, when we started creating the Spring Cloud Gateway, which is, again, fully reactive, from the very first commit, it was publicly visible and available on GitHub. And it's very, like everything else, has a wide variety of contributors for that very reason. So 100% open source, 100% available, visible early on. Everything you saw here today and more is out under my Reactive Spring Deep Dive repository. And it actually works, every bit of it, including the crazy tests and the crazy Kotlin stuff. So by all means, please do check it out, and please follow me so I can let you know what I did weird with the Kotlin one here. Something obvious, I'm sure, that I just missed. But that's what makes life entertaining, right? And keeps you humble. So if anybody is in the US this September and want to know more and really drink deep from the well, Spring One platform is going on in September. Save yourself a few bucks and register with a discount code. If you think you can make it, by all means, again, get all the knowledge for a couple $100 less. So if you can make it, great. It's actual committers, developers within Pivotal, as well as external to Pivotal, who are hitting you with the full force of the fire hose. So it's a deep drink every session. So thanks for coming today. I do have some time for questions. So we'll stop there and we'll do questions. Oh, thanks. Thanks so much. I'll go back to this because a lot of times people say I didn't catch those. So, okay, any questions? Way in the back. Yes.
Yeah, I'll try and talk loud.
Okay.
So it might be a bit of a basic question. It's more about the event streams than Spring Reactive. So I was kind of wondering, so you make a request to the server and sort of socket connection, and the data starts coming back. You're not tying up a thread in Reactor, you're not tying up a thread to that connection, right? So when you're coming back more data each second, how is the sort of socket connection maintained? You haven't got a thread type on the server, you've got some part that's reacting and sending data across to the client. How is that connection kind of maintained?
That is further down the stack, the network stack, than I am familiar with, to be honest with you. Although I am glad you brought this up because it allows me to mention something that is more in line with this. But I don't know, honestly. I honestly don't. How the network stack actually handles that. I suspect that, obviously your operating system is responsible for maintaining those connections. It's just that it doesn't tie up your applications. So again, it can churn through and then pick that particular socket back up and communicate over it when it needs to. But for other reasons entirely, I'm glad you brought that up because there are different schedulers. Sometimes people ask, okay, well, how do I manage my threads? How do I handle my schedulers and deal with that? The good news is you don't have to. By default, out of the box, Reactor will create as many threads as you have cores. Just by default. You can control that. You can scale that up or down. You can also you can use executors, you can use schedulers. You can use schedulers that are baked in. So you have things like your parallel pool that you can reference and leverage. You have an elastic pool of schedulers that can be used. Typically that's used when you have blocking requests because you will sometimes have to deal, it'd be lovely if everything was non-blocking and reactive, but there are going to be times you have to kind of step outside that fence and interact with a blocking system. So you don't want to slow everything or stop everything, I should say, to a halt, bring everything to a halt when you're doing that. So you can use the elastic pool of schedulers to farm out, if you will, those different blocking requests. Let's see, what else was I going to mention that? Oh, you have operators, so you can actually leverage those various different pools, create a specific scheduler to deal with a publisher with a publish on method. You can also subscribe on a particular thread, a particular scheduler, if you use a subscribe on. So you have very fine-grained control. The good news is you don't usually need to use that because Project Reactor is very good about maintaining that and managing that for you, so you don't have to 99.99% of the time. Let's see, what else? The hot and cold publishers. Generally speaking, your publishers are cold, so no work happens until you have a subscription, until you have a subscriber that subscribes to that particular publisher. But you also, and I mentioned earlier, one example of a hot publisher is just, because when you create a flux, as I like to say, of just these values, it actually creates that publisher and then does a replay when anybody connects. But you do have, again, a lot of flexibility, a lot of levers you can pull that, generally speaking, you just don't have to do for optimal performance, for optimal resource utilization. But those are a couple of questions that always seem to come up from time to time, and I like to address them throughout, and I kind of mentioned the one and forgot the other entirely. So, anyone else? We have a minute. I'll come back to you. Yes.
Okay. This is kind of a more generic question
Uh-oh.
about reactive streams.
Okay.
Have you? I found when working on projects such as these, and especially when dealing with onboarding new developers, they've found reactive streams quite difficult to wrap their brains around. I mean, I certainly did when I started. That's definitely true on the back end. I mainly do stuff on the front end, where
Okay.
I also use reactive stuff as well. Have you? Would you recommend anything as a kind of way to kind of ease people in, or would you could you talk about making reactive streams, reactive programming more accessible to people into it?
Well, and that's a great question that'll take me a little longer to answer than probably what I'd like, but I'll give you kind of the thumbnail. I think there are two aspects of reactive programming that I think really are the biggest obstacles to people picking them up and using them well very quickly. One is the fact that in many cases, many libraries, vendors' approaches are dramatically different from what they're used to doing on a daily basis. And that's where I mentioned that I think if you stay with the annotation model, you're on very familiar ground. Instead of returning an iterable, you're returning a flux. Instead of returning a type of object, you're returning a mono. So that helps with that tremendously. The other side of that, though, is just the mechanisms, the expectations that code executes one statement at a time. This statement executes only after this one above it is done, and chaining operations together. So that's a little bit harder to get used to and get your brain wrapped around. I don't find it that onerous, especially if you have come from a lot of streams work in Java 8, and you're familiar with lambdas and you use that a lot. If you're working on an older code base, it is. I mean, if you recall when you first stepped up to Java 8, there was a lot of this kind of anguish that you've forgotten by now because it's been 3+ years ago. But that was a lot of change that hit, and it's like, wow, that's a huge amount to kind of digest all at once. Again, now in hindsight, it seems so trivial, but I think if you're coming from a heavy Java 8 use where you actually do a lot with streams and chaining the operators together and the terminal operation, it seems like a very natural extension, but otherwise it just takes longer. So I guess my summary is, if you're coming from a Spring MVC and going to a Spring Web Flux, half of that goes away largely in terms of the cognitive load. The other half, it's just a matter of how familiar you are already with Java 8 and the pain points. So yeah, I want to get your question, and then we're out of time, but I do want to get your question. Then if anybody has anything else that they want to talk about, like I said, I'm here for the next couple of days, and then I'm on Twitter forever, or till whatever.
So I have a question about one of your
Yes.
Does the framework actually support adding new type of transport? And if yes, then I would say how easy it is.
Again, that's at a level that I don't deal with, to be honest with you. I'm sorry. Oh, I thought somebody threw out the answer to that. I don't know 100%. I'm under the impression that you can add various different transports. I just don't know how difficult that would be. I do know just mechanically, WebSocket is a little more difficult to pull off, and frankly, that doesn't bother me too bad because when you're talking about a publisher, you're talking about a pulse feed anyway, which server sent event seems like a very natural fit. But that's even with a currently supported mechanism over upgraded HTTP. So I don't know. But that is kind of a good question.
The one I have in mind is actually shared memory.
That was what I was going to say. Well, so what are you thinking of? Yeah. Oh, interesting.
How feasible would that be?
I have no idea. I never had that question, but that's an interesting one. I don't know. Okay. Well, anyway, thank you so much for coming, and have a great DevOps.